right? See how you are supposed to, let's say, take the advantage of this session or let's say, utilize this session to the best of your understanding. So first of all, let's say the first half is going to be mostly theory, all right? It's mostly going to be theory. We are going to understand the essentials of LLMs and let's say stuff related to the same. And the second half is going to be the practical part. All right. And as far as the practical part, where we'll be, let's say, creating a chatbot. For the practical part, we are going to create a chatbot. Now, these days, whenever let's say, if you're applying for any machine learning or let's say deep learning related role, majority of you, or let's say the chances are high that you might end up getting an internship at assignment or let's say a project based on chatbot where you need to create a chatbot based on LLM, right? So to cater to that requirement, it's imperative that you understand whatever we are discussing in this session. All right. So as far as the theory part is concerned, we'll discuss about the LLMs and stuff, and the practical part will be on chatbot building. So few essentials that you, let's say, few prerequisites. So of course you need to have Jupyter installed. Let's say Jupyter or Anaconda. Then let's say you need to have VS Code. We'll be working on VS Code, and you need to have Python installed in VS Code as well. All right. Next, so I just want a confirmation from you all whether you're using, let's say, ChatGPT using the same Gmail ID, or is it using a different Gmail ID? I'm asking this question because suppose you're using ChatGPT from the same email ID using which you have logged in as of now. So most likely your $5 free credit might have expired, right? So if it is same, do one thing. Maybe you can create another email ID, another Gmail account, where you'll end up getting $5 free credit. That is how you'll be able to utilize it. See, we need to set up OpenAI API key, right? We need to set up OpenAI API key. Now, whenever you, let's say, sign up using new Gmail, we get $5 credit. All right. So most likely, if you're using the same email ID, you won't end up. You might have utilized your $5 credit already. So either you can log in using a different Gmail account or create new Gmail account if needed. All right. Or you can create a new Gmail account if needed. All right. So these are the things required. So we need an OpenAI API key. And in case this is not the case, then let's say, otherwise you need to make payment. You have to make payment for the same if you're supposed to implement this. All right. I've already set up my account. It might have exhausted as well. So I'll just check it up. Otherwise, I'll make the payment for the same. All right. So these are the prerequisites as far as the practical implementation is concerned. All right. I'll be sharing all the files towards the end of the session, as in Jupyter, and yeah, one more thing. We need MySQL as well. MySQL as well. MySQL workbench. And maybe shell. These are some additional requirements. See, we are going to create, we'll be creating two, let's say, chatbots. See, you can use the past account provided you have not utilized your $5 credit. If you have already consumed your $5 credit, then you might need to create a new, let's say, Gmail account, or maybe you need to make the payment. All right. Or you have to make the payment. So please ensure that you have, let's say, VS Code installed, MySQL installed as well. And let's say Jupyter, I'm assuming, is already installed in your system, right? So these are the prerequisites. So the, let's say, objective of this session is, let's say, whenever you are applying these days for any ML or let's say TL based role, so you do come across multiple, let's say, chatbot related, maybe internship assignments or maybe job related assignments, right? So you must have a fundamental understanding about how we are going to create chatbot in the first place. Let's say what all it takes to generate a chatbot from the scratch, and maybe let's say, so we do have the concept of multimodal architecture. We'll have a discussion about the same as well. So that depends on the token. That depends on the token that how much tokens you have utilized. All right. It completely depends on your usage. Is it clear? All right. So guys, over here, I'm going to let's say switch to the PPT part. Yeah, the recordings will be provided maybe after a couple of days, maybe tomorrow or day after tomorrow. All right. So assuming the screen is visible and I'm audible, I'm getting started with the session. So those who have joined later, guys, again, I welcome you all to this masterclass on building chatbot using LLM. So let's have a look at the agenda for this session. So first of all, we are going to understand the basics of LLM. All right. Moving forward, we are going to understand why LLMs after ML and DL. So there's another basic prerequisite which I missed that is not meant for the practical part, but for theory part. You must have some understanding about machine learning and deep learning, right? I see. So I'm assuming everyone present over here has some understanding about machine learning and deep learning. If not partially, we are going to have a discussion about the same. All right. So when we are talking about LLMs, we are talking about a concept, let's say, uh, which is considered light years ahead compared to something known as machine learning, and much further, let's say, advanced compared to something known as deep learning, right? So we'll have a discussion about ML and DL as well in brief. And then we are going to understand how to generate and set up API key for, let's say, OpenAI and Gemini. All right. OpenAI being the, let's say the majority of the projects that you'll come across these days, they do come from OpenAI. So we can utilize, we'll be utilizing OpenAI, but I'll also show you how to set up, let's say, API key for Gemini. Then we are going to understand the role of vector database. All right, we are going to understand different types of vector database that we have and the commonly ones which we are going to use. Then a very important concept that we'll be, let's say, discussing, that is going to be RAG. All right. And we're going to understand why to learn chatbot building in 2024 and what was the scenario before, let's say, LLMs came into picture, how the chatbot building has transformed, let's say, over the years. Then we're going to understand the steps for building the chatbots, utilizing LLMs. And then, let's say, we'll be building chatbots using LLMs, maybe chat with PDFs, chat with database. And if time permits, we can go through some other multimodal chatbots as well. All right. So guys, is the agenda clear? Screen should be visible. You can check. All right. So guys, I hope the agenda is clear, right? All right. So as discussed, first half is going to be mostly theoretical, and then post, let's say 12 or 12:30, we can proceed with the implementation, the practical implementation, right? All right. So I'll show you the documentation as well. So where we can have some better understanding about, let's say, LLMs and LangChain and what all things are required. All right. So let's have a look at the takeaways. So the objective over here is that, let's say, you can understand better, you can understand the concepts of LLM and their applications. All right. You'll be able to master the essentials of chatbot building. So you'll understand the fundamentals and what all things it takes. And let's say, partially how it works. All right. See, when we're talking about deep learning and let's say concepts beyond deep learning, essentially we are taking into the domain of black box models. All right. So the practical implementation won't give you an idea exactly how they are working. Then another takeaway is you'll be able to, let's say, create a RAG-based chatbot with PDF from various domains. So I do have PDFs from, let's say, some horoscope-related PDFs, some budget-related PDFs. All right, so we can utilize that. Maybe we can use some medical, let's say, healthcare-related PDF as well. And then we are also going to build a chatbot that interacts with MySQL database. So for that, we can pick up any data set, let's say from Kaggle. All right, we can store it in a database. And then we can, let's say, query that database in the table utilizing the chatbot. And there's one more thing that will be required. That is going to be Streamlit, right? So guys, basically, even in the previous master session, we have worked on, let's say, chat with PDFs. But over here, we'll be creating an entire application, right? In the previous master session, what we discussed was mostly based on Jupyter Notebook or I guess Colab. But as far as this session is concerned, we'll be creating a chatbot as in a complete chatbot. So we'll be utilizing Streamlit. So in case you guys are not familiar with Streamlit, so there has been a previous masterclass on the same. All right. So I hope some of you might have gone through the previous masterclass as well. Guys, have you guys attended the previous masterclass on, let's say, Hugging Face and Streamlit? All right. So guys, those of you who have attended, they have some idea about Streamlit and how to utilize Streamlit. So Streamlit is essentially a framework. All right. All right, no issues, no issues. So as of now, see, those of you who have not attended this, we just need this framework, right? It is a Python, let's say, framework used to create web applications. See, when you're interacting with ChatGPT, you're running it in a browser, right? You're running it in a browser. So likewise, we need to create a web application. So for web application, we need to have Streamlit framework. So those of you who have not attended this session or let's say Streamlit is not installed, what you can do? Over here, you just write in Jupyter, you can just write if install Streamlit. Just execute this. Just execute this, or maybe we'll be creating, let's say, a virtual environment and we'll be installing certain dependencies. So either you can install now, or maybe towards the second half of the session, we'll be again installing it. Is it clear? This is another requirement. We need to have this framework, all right? This is the framework on which we are going to build up the chatbot. For both the chatbots, let's say the PDF one and the one with the SQL, we'll be utilizing Streamlit along with demo. Okay, see, the installation part, I guess, means if you have covered through machine learning. So I guess VS Code and Jupyter installation, this part we can, you can do it on your own, right? This will be discussed. All these things will be discussed. 3 and 4 will be discussed. All right. If you have covered through machine learning, so I don't think installing Jupyter or VS Code or MySQL should have been an issue for you. All right. Streamlit we are going to install. And OpenAI API key, how to set it up, this we are going to discuss. That's in fact even an agenda for the session as well. How to generate and set up API key for OpenAI, this we are going to discuss. Clear to everyone? All right. So guys, these are the key takeaways. Means see, we'll be discussing with MySQL, but it's not mandatory that you use MySQL only. You can connect with, let's say, you can also connect with Postgre. You can connect with SQL Server. You just need to have the connection string, right? You just need to have the username, password, the host name, and the port number, utilizing which you can connect to these different databases. I'll show you the documentation as well. All right. So let's say when we're discussing about LangChain, so we'll have a look at the documentation as well, right? See, documentation, make it a practice to go through the documentation. That gives you an idea about how, let's say, things are working in the background. All right. What are new functionalities? What are the new classes that, let's say, that are coming up as far as a particular documentation is concerned? Documentation is of much concern, especially we are dealing with advanced concepts, highly advanced concepts such as LangChain or LLMs. So I'll show you the documentation as well, how to all right, just yes. See, what was there in the LangChain maybe 2 years down the line is now no longer utilized. So that is why going through the documentation is imperative. All right, a lot of new things are coming up. A lot of new things have already, let's say, been utilized in the industry previously, which was not present. So I think everyone is joined. Right. So do we have more students waiting? No, all right. Okay. So we are getting started about it. So guys, just have a look. Let's understand LLMs in the first place, right? See, LLMs stand for large language models. So LLM is a type of, let's say, artificial intelligence model designed to understand and generate human-like text based on large-scale data sets. LLMs, as in the name itself, is comprised of large language models, right? So LLMs, let's say they are trained on very large amount of data. When we are talking about very large amount of data, we can expect data in the range of maybe petabytes or even more, and even zettabytes. All right. Let's say we can consider that these LLMs are trained on the entirety of the internet or a majority of that section as far as the training part of LLM is concerned, right? So we are talking about a highly advanced AI capability or AI technology that is capable of generating human-like text based on, let's say, large-scale data sets. All right. So obviously, the objective over here is to generate human-like text based on large-scale data sets. So LLMs are trained on vast amounts of data, of text data, allowing them to learn the intricacies of language, including grammar, context, and even subtle nuances in tone or even the intent. So let's say those of you who are familiar with deep learning, so you do understand, right? Let's say we might end up facing certain challenges when it comes to text classification, let's say for sarcastic comments. If you're supposed to analyze or let's say predict the tone or sentiment for sarcastic comments, that is where even deep learning models may falter. Are you getting the concept? Are you able to understand what do we have on plate when we're talking about LLMs? As of now, let's just understand that it is a highly advanced AI model that has been trained on an extremely large data set. All right, with the sole purpose of, let's say, understanding and generating human-like text. The way we, let's say, interact, let's say, the way we converse, that is what, let's say, can be assumed as the end goal of an LLM. All right. Now, to better understand LLM, we'll further take it down. So a large language model is a type of artificial intelligence algorithm that applies neural network technique with lots of parameters to process and understand human languages or text. So guys, are you familiar with neural networks? Are you familiar with neural networks? All right. So when we are talking about neural networks, right? I'll give you a brief idea. Those of you who are not familiar, see, when we say we are talking about a neural network, right? So the way we have neurons in our brains, right? The way we have neurons in our brain, how does human brain perceive a particular information? First of all, we receive certain stimulus or some input. Then the nerve cells undergo certain pre-processing based on that input, and then a response is propagated. Are you getting this? And then a response is propagated. So this is, let's say, a general architecture of a typical neural network. This is how, let's say, we can assume a neural network looks like. So on the left, we do have, let's say, a couple of neurons. This is referred to as the input layer. Then we can have multiple hidden layers, and we can have one or multiple output layers. And these input layer, hidden layers, and output layers can be, let's say, realigned to fit a particular problem statement. They can be programmed and they can be customized to fit a particular problem statement. All right, so this is just a very fundamental or a very basic neural network. This is just an architecture. When we are talking about actually implementing a deep learning problem statement in the industry, essentially we'll be dealing with a highly complex and most likely a deep neural network where we'll be having multiple neurons to begin with. All right, multiple neurons, multiple layers, and multiple, of course, and multiple output layers as well, depending upon the kind of problem that we're dealing with. Now, so deep learning can also go to, let's say neural networks with very high, large number of neurons or neurons, let's say neural networks with high number of hidden layers, right? That is referred to as deep neural network. Now, going further beyond that, even when we're training a neural network or let's say a deep, a deep learning model, right? So essentially, we do come across, let's say, architectures where we do have, let's say, when we're talking about trainable parameters, right? We talk about something known as trainable parameters. So this number goes into, let's say, it can go into thousands, and it can even go beyond that, right? So usually this is the case with neural networks. This is the case with neural networks. So the number of trainable parameters that we have in neural networks that can go into thousands and even lakhs and even beyond. Are you getting this? But when we are talking about something known as LLM, right? So the number of trainable parameters that we have over here, they start from billions. Are you getting this? The number of trainable parameters that we begin with, they start from billions when we're talking about, let's say, LLMs. So just think about the complexity, think about the architecture of the LLM, right? Now, when we're talking about trainable parameters, for those of you who are familiar, we are essentially talking about weights and bias. So the sum total of, let's say, weights and bias for, let's say, a very basic neural network can go up to thousands and even lakhs and even more. But when we're talking about trainable parameters for LLMs, all right, the starting point would be some billion, all right, some billion number. So if I were to show you what is this number that we're talking about, so let's just take parameters, all right, in GPT-4. Just have a look. How many parameters are we talking about? How many parameters are we dealing with when we're talking about GPT-4? We are talking about 1.76 trillion parameters. That is the number of trainable parameters that we do have in GPT-4. All right, okay, let's go to GPT-3. So GPT-3 comes up with 175 billion parameters. That is the extent to which it is capable of expanding its learning. See, the more the number of parameters, the better the model is capable of learning, the better the model performs in terms of its metrics, be it accuracy, be it some advanced metrics like blue score, etc. All right, then we have 3.5. So it is saying somewhere around 175. But let's say now, look, GPT-4 being in picture. So over here we have 1.76 trillion parameters. Just think of the amount of data that it might have been trained upon, that it is capable of generating, and it is capable of being trained on 1.76 trillion parameters. Are you able to, let's say, understand the picture on a larger scale? What is the kind of data or what is the kind of learning that we're dealing with? Guys, are you able to understand the scale at which we are referring to? The training, the learning part, it's extremely huge, all right? It's extremely huge. So that is why when we are dealing with, let's say, deep learning and even LLMs, we are talking about black box models, all right? We won't be able to see what is happening in the backend. We won't be able to understand or comprehend what is happening in the backend. At the max, you can go through the documentation and let's say maybe practice the same concept with a couple of different data sets, couple of different maybe architectures, and then you'll be better able to understand the concept. Yes. All right. So when we're talking about LLM, so LLM is a type of artificial intelligence algorithm that applies neural network techniques with lots of parameters to process and understand human languages or text. Now, if you are familiar with deep learning, you might have an understanding that the larger the amount of data, the better the model performs. That is why when we are training deep learning models, it is advised or recommended to utilize a GPU. Rather than working on CPU, we do utilize GPU as far as the deep learning models are concerned, right? So even for LLMs, let's say it is advised or recommended to utilize GPUs, all right? But as far as the web applications are concerned, it's not everyone might be having a GPU-based system. So that is why we do have Google Colab, right? In Google Colab, we can utilize the GPU, but only one session at a time. So if at all you wish to, let's say, implement LLMs on your own, so try to utilize Google Colab, right? There you'll be able to implement all the things, except let's say for the web app part. And even we can implement Streamlit or maybe Flask in Colab as well. We do have certain frameworks for conversion. So for Jupyter, if you need to run it on GPU, you must have, let's say, a graphic card installed in your system. You might be having, let's say, NVIDIA or CUDA-based graphic cards. Then you'll be able to set up GPU in Jupyter. Now, let's extend the conversation further. Yes, as I mentioned, the recording will be shared, right? The recording will be shared by tomorrow or maybe by day after tomorrow. So let's extend the conversation. So LLM, as discussed, is a type of artificial intelligence model designed to understand and generate human-like text based on large-scale data sets. Now they're trained on vast amounts of text data, allowing them to learn the intricacies of language, including grammar, context, and even subtle nuances. Large language model is a computer program that learns and generates human-like language using a transformer architecture trained on vast training data. Now, transformers, let's say 4 to 5 years back, or maybe around, let's say before the onset of ChatGPT, transformers were considered to be the, let's say, pinnacle of AI. All right. Transformer models were considered to be the pinnacle of AI. All right. Because transformers model were capable of performing all the, let's say, highly advanced functionalities of AI that were otherwise considered quite complex. Means just understanding transformer model itself is, let's say, kind of gigantic task. I can show you a couple of papers. See, to understand transformer models, you must go through this documentation. Now, this is the starting point, let's say, where LLM stems from. If you need to understand the background mathematics, all right, you must go through this documentation. See, over here, you'll find a highly complex architecture. Keep this in mind. This is the starting point. If you need to understand the mathematics of LLM, how the LLMs are working, how they are trained, all right, and how they are able to generate the predictions, We'll have a brief discussion about the same as well. But this documentation is a must go through documentation if you wish to understand transformers and if you want to deep dive into the mathematics of LLMs. So this is a typical architecture of transformers. All right, hence I can share you this link. So over here we have some input embedding, then we do have some multi-head attention, then let's say the feed forward mechanism. So over here we have positional encoding. This part of the architecture is for input, and this is where we do end up receiving the output. All right, so this is, we have multi-head attention. Over here we have masked multi-head attention. So you need to go through this documentation. Means there are simplified versions of this documentation available as blogs, available as videos, just to help everyone explain and understand the concept of transformers, how they're working, how they are trained, how they are optimized, how to tune them, and everything else. All right. So consider this as the starting point or the beginning of where we can proceed with LLMs. Right. So I've shown you just the transformer architecture. Right? This is one of the most complex architectures as far as any deep learning model is concerned. Compared to any deep learning model, unless and until it is an advanced version of transformers, this is the most complex architecture prior to ChatGPT and LLMs. Correct? We are talking about let's say era or time zone prior to ChatGPT. At that time, transformer was considered one of the most complex architectures compared to any other deep learning models. Let's say parallelly and equivalent to maybe reinforcement learning, complex architectures of reinforcement learning. I hope you're getting the context that, let's say, LLMs means you just have a look. You won't be able to understand it, how they are working, because essentially they are the black box model. Okay. Right, I'm sharing this link in the chat. Yeah, I've shared the link in the chat. So you need to understand the attention model and the transformer models, let's say, to further understand how the LLMs are trained, how they are working, and stuff. All right. So when we're talking about LLMs, right? So LLMs use deep learning algorithms to process and understand natural language. All right. Now LLMs can perform many types of language tasks. So what are the tasks that we can implement using LLM? Let's say some common tasks are translating languages, analyzing sentiments, chatbot conversations, and more. They can even understand complex textual data, identify entities and relationships between them, and generate new text that is coherent and grammatically accurate. So this defines the, let's say, applications of LLMs. Right? This point defines the application of LLM. Think in terms of the industries. Think about the industries that do utilize chat-based applications. All right. These days, or let's say from quite some past years, we do get to see different chatbots do pop up on websites like, let's say, Zomato, IRCTC, Ola. They all have their chatbots, right? Now, since the onset of ChatGPT, maybe from 2023 and onwards, you might have seen some AI-based features on these chatbots. Yes. Have you seen these AI-based features on these chatbots? Suppose you're querying Myntra or maybe you're querying Zomato. So prior to ChatGPT, we were only able to search for a particular restaurant or a particular food item, right? Yes or no? Now, if you open, let's say, if you have subscribed to Zomato Gold, are you able to search for even customized food options? Suppose I can search for healthier breakfast or healthy breakfast, rich in protein. I do have such options if I have subscribed to Zomato Gold. All right. Likewise, I can search for a specific maybe brand or a specific type of maybe clothing apparel on Myntra as well. Have you explored these options? Have you explored these options? Suppose I want to, let's say I don't want to go for a particular brand. I just wish to search maybe beach wear, all right? Beach wear or maybe party wear, formals. Formals is a common term. So you can explore certain nuances when we are talking about, let's say, embedding uh, LLM-based chatbots even on these platforms. So an LLM-based chatbot is capable of, I'll repeat, an LLM-based chatbot is capable of analyzing sentiments, translating languages, chatbot conversations, and more. All right. These days, let's say building chatbots and customizing them, fine-tuning them, optimizing them. Let's say industries are heading into these domains because they have, let's say, huge amount of data. They have huge chunk of data, right? And they want to, let's say, their clients or maybe their applications might have a requirement where they need to interact with the data, where they need to extract a particular information or relevant information based on a specific context. So this is where LLMs comes into picture. Even we can embed or let's say integrate maybe an image-based chatbot with a text-based chatbot as well. We do have those capabilities as far as the multimodal architectures are concerned. So try to picture them on a larger scale. Try to picture these concepts on a larger scale to have a better understanding, right? So LLMs are characterized by their large size, often having billions of parameters. We just discussed this. And we're talking about LLMs, we're talking about billions of trainable parameters, right? The scale of these models enables them to handle complex tasks and even generate more coherent and contextually relevant text. All right. So it's imperative to generate contextually relevant text. Now, I'm assuming everyone over here has utilized ChatGPT. Yes, at least once you have used ChatGPT. Yes or no? Okay. How many of you have seen ChatGPT falter? How many of you have seen ChatGPT falter at times? Have you seen ChatGPT generating, let's say, irrelevant responses? At times, even for the simplest of the questions, it ends up generating incorrect responses, right? Not always. I'm not saying always, but at times. And it's not just about ChatGPT. It's the same case with Gemini. It's not just ChatGPT that ends up generating incoherent or irrelevant responses. It is the same case with any, let's say, chatbot that we do have for free. See, what is freely available definitely is bound to be, let's say, not that great. Are you getting this? Why are we offered ChatGPT for free in the first place? So that we do understand its limitations, so that the OpenAI can sell their, let's say, the pro version to those who have already, let's say, understood or maybe who have already utilized the limitations of ChatGPT, right? So even though when we are talking about, let's say, grammatically accurate, we are talking about generating text that is coherent, still we do end up getting errors, right? So even a model or an architecture that has been trained on, let's say, billions of parameters, still it is capable of generating errors. So the state of perfection that is, let's say, essentially characterized by the metrics. When we're talking about any LLM, we do have certain metrics as well, let's say, to weigh the performance. And these days, if you have been following, let's say, any AI-based maybe blogs or maybe AI-based technological advancements, so you might have come across that every month or let's say every couple of months, there's a new LLM model that is capable of outperforming its predecessors. Yes, every month there's a new model that has been, let's say, outperforming its predecessors. So all of these companies, let's say all of these, let's say tech giants, they're all into a great competition, right? So we have Google, we have OpenAI, then we have, let's say Apache. Then there are a couple of other companies as well, right? We have Microsoft. They're all into the race of generating the best possible LLM. all right, or at least outperforming the previous best LLM. So there has been news circulating about GPT-5. All right, maybe by the end of this year or by the beginning of the new year, we might get a glimpse of the same. GPT-5 is on the way, and we might get a glimpse of the same in by the beginning of the new year, or maybe by end of this year. All right. So most likely, definitely by let's say by next year, we'll have ChatGPT 5. As far as the advancements are concerned, ChatGPT 5 is on the way. So think about it. When we have already discussed what is the number of parameters in GPT-4. So we do have 1.76 trillion parameters. All right. We do have a model that is capable of outperforming its predecessors based on 1.76 trillion trainable parameters. But still, let's say the state of perfection has not been achieved. Why each of these tech giants are coming up with, let's say, new LLMs or new, let's say, architectures? Because they claim, or let's say, it's not just a claim, means there has been proof for the same that a couple of LLMs do have the capability of outperforming the other LLMs, right? In terms of performance, in terms of there are n number of metrics. Are you getting this? All right. So the scale of these models enables them to handle complex tasks and generate more coherent and contextually relevant text. Now, let's understand certain applications of LLM. And I think we have discussed this even in the previous masterclass that was around that was on prompt. So the applications remain the same. So we can utilize this in a couple of industries, right? We can utilize this, let's say, in telecom. So LLM powered, so these days we do have agents as well. So LLM powered agents for customer inquiries in any written voice channel. All right. So in telecom industries these days, you might have heard, let's say that the suppose you call a customer care, right? Previously, there were let's say actual humans who used to cater to the queries. These days, we hardly find any humans catering to the queries, especially for let's say customer care support. Have you observed this, guys? Have you observed this scenario? These days, do we encounter real human, let's say, assistants to handle customer care support? Yes, means I'm not saying they have completely eradicated the system, but their frequency has declined, right? The frequency has declined. We have more and more, let's say, voice-based assistants or maybe inbuilt app help section where we can report our queries and then it will generate a token and then maybe within a couple of days the token will be resolved. All right. So we do have virtual assistants to guide users in resolving connectivity issues. All right, utilizing images and videos. Suppose you buy a product from Flipkart or Amazon and maybe the product is faulty. How would you get a refund? You'd have to upload the images, right? You'd have to upload the images. So LLMs are also utilized in banking. So automation of processes that require analyzing large quantities of documents. So this, it's analyzing large quantities of documents. Again, this can be done using an LLM. So we do have financial AI advisor. All right. Then LLM-driven financial advice tailored to individual customer profiles, which with better user experience. So as far as the banking domain is concerned, so they're coming up with AI advisors. So essentially, they are LLM agents that have been trained on the previous financial advices and the data. And that is how they're giving financial advisors to investors, to let's say promoters, to retailers, etc. The same thing applies to insurance as well. So automate claim processing with image recognition to assess damages. So you might have observed or you might have come across a situation where, let's say, we have maybe registered for a particular insurance, but at the time of claim, we do end up getting some issues, right? They deny that under a particular scenario, maybe the insurance was not regulated. So this entire process, let's say, can be automated. We can automate claim processing with large image recognition to assess the damages. precise risk assessment, LLM generated personalized policy recommendations based on user data. So even the insurance industries are using the LLMs. Then as far as the airlines are concerned, so we can deploy virtual assistant for efficient customer service and other personalized travel solutions. And we do have image recognition for regular maintenance and safety checks. So as you can see, all these industries are utilizing LLMs. And it's not just these industries, we have other industries as well. We have retail industry. So as far as the retail industry is concerned, have you come across a situation, let's say, where the entire grocery store is monitored by an AI? It's not in India. You might have come across such videos on YouTube, maybe for a different country, where the entire grocery store is operated by an AI. Have you seen such videos? Means from payment to entry to purchase of the product to the transaction, everything is controlled by AI. All right. And even they do have the inventory management system as well. So that is where LLMs come into picture. So LLMs combined with multimodal architecture can generate out of, let's say, excellent results, right? So in the retail industry, and they enhance the shopping experience with personalized recommendations. They manage inventory through advanced image recognition. They analyze market trends using AI to forecast the demand. Yes, definitely. So we do have LLMs in healthcare as well. So they can assist doctors in diagnosing diseases with medical imaging analysis, and they can help the doctors to interpret medical images and reports for quicker diagnosis. All right. Now, they can assist doctors to develop, let's say, personalized treatment plans using the patient data. They can provide virtual health assistance for routine inquiries and patient monitoring. Now, there are a number of apps on Play Store that you might have seen that can give you a routine around your health, let's say wherever your health lacks. Yes, we do have a number of apps related to health that can generate a tailor-made output for your entire routine, for your entire lifestyle, for your entire, let's say, right? Yes. Have you come across such applications? They can generate your entire diet plan based on your health diagnosis. You provide them with certain details about your health, about your age, about your body weight, about your food intake, and about your routine. They can generate an entire health plan for you because they have been trained on such kind of data. So that is why we do have such applications in the first place. So again, there are, let's say, outcome of LLMs. Now, even in the entertainment industry, let's say, be it some OTT platform, all right. So LLMs can generate and recommend content based on a mix of user preference and behaviors. All right. Now, LLMs can even create immersive learning experiences by combining text, images, and audio. So even in the, let's say, education industry, LLMs can be utilized, and they have been utilized in certain education industries as well, right? So guys, I hope you have an understanding about the applications of LLM. Yes, is this clear to everyone? Is this clear to everyone? All right. Next, let's have a look. Let's try to understand what are some popularly used LLMs. So as far as the GPT family, let's say they started with the chat GPT. So we do have, let's say GPT 3.5. So that is the default GPT version that we are all using, provided you have not opted for the Pro. All right. Then we have GPT 4.0 and 4.0. Then we have Mistral, we have Claude, we have Llama, we have Gemini, we have Gemma. Other than these, we have a couple of others. All right. Other than these, we have a couple of others LLMs, right? We have a couple of others LLM. So these are the most, let's say, challenging and the promising LLMs that have come to the surface. There are a couple of other LLMs, let's say, that have not outperformed them. So you might have come across these names. Definitely, we are all familiar with, let's say, we have definitely come across the terms, right? GPT 3.5 and 4.0. So some of you who have been following LLMs, they might have come across these terms. We do have Mistral, we do have Claude, we do have Llama, we have Gemini, all right, and we have Gemini. So there can be other LLMs, and let's say every new month or maybe every 2 months down the line, we do come across new LLM that is capable of outperforming the previous LLMs, right? These are the common LLMs that we use. Now, suppose means as far as the practical implementation for this session is concerned, we'll be utilizing GPT 3.5. All right. Now, in case you wish to utilize other models, so you can utilize them. So for that, you need to go through the documentation for Hugging Face. You need to go through the documentation for other, let's say, models as well. All right. Now, let's understand on the surface what it takes to train an LLM, right? What comprises of the training phases or how the LLMs essentially work in the backend. I'm just giving you an overview, right? I'm just giving you an overview. It's on the surface. This is just the surface level of the training part. All right. So the efficacy of an LLM comes largely from its training process. When we are saying that, when we're claiming that LLMs are so accurate and reliable, so essentially we are claiming that it's high on efficiency, right? So what goes into the training part of LLM? Let's understand this. So essentially there are 2 to 3 phases. Over here I've mentioned 2, but there's another phase as well. So there's a pre-training phase, there's a fine-tuning phase, and then there is RLHF. So when we talk about the pre-training phase, right? So over here the model is exposed. Let's say we are talking about LLMs. So over here the model is exposed to massive amounts of text data, such as books, article, or let's say web pages, or a major section of, let's say, internet, depending on the context. All right. So the model, let's say any particular LLM is exposed to massive amounts of text data. It can be books, article, or even web pages, so that it can learn the patterns and connections between the words. All right. The more data it is trained on, the better it will be at generating the new content. So we need to feed in with more and more relevant and contextual data so that it can, let's say, learn better. So by doing so, it learns to predict the next word in a sentence. Essentially, let's say when we're talking about LLMs, we have discussed this that LLMs are generative models, right? They are capable of generating human-like text. All right, we are talking about a model that is capable of generating human-like text. See, they generate human-like language, right? So essentially, they are all generative languages. So they have the capability of generating. Now, to be able to generate, let's say, words or responses, they need to learn to predict the next word in a sentence, right? This is where the ability to generate stems from. When we are talking about, let's say, text generation, so we are essentially talking about generating words in the first place, right? Text, the entire text comes from the word, and words do comes from the alphabets, right? So we need to generate words in the first place to essentially be able to generate the entire text-based responses. All right. So through billions of such predictions, the model learns the grammar, facts about the world, reasoning abilities, and even some biases present in the data. That is how, let's say, the pre-training works. In pre-training, the model goes through, let's say, we feed the LLMs with extensive amounts of data, all right, onto which the model is getting trained upon. Then the next part is the fine-tuning. Next part is the fine tuning. So after the initial pre-training, the model can be refined on a narrower data set to specialize in the specific task or knowledge areas. This helps in aligning the model's responses with the desired outputs. Are you getting this? Guys, can I get a response if these two, let's say, working of LLMs is clear to everyone? So there's a third point as well, which over here I have not mentioned. The third point is RLHF, reinforcement, let's say, learning with human feedback. Now, the response that we need should be in a human, let's say, comprehensible format, right? There's the response that you get out of ChatGPT. Are you able to comprehend it? Yes. We are able to, let's say, understand the response from ChatGPT or from Gemini. So this is where RLHF comes from. All right. This part of the training is referred to as reinforcement learning from human feedback. All right. Now, let's come to a very important question. Now, suppose you have covered machine learning, suppose you have covered deep learning, right? Now, why LLMs? Why LLMs? After, let's say, machine learning or deep learning. It's not just because, let's say, it's obviously it's highly in demand. And let's say these days industries are looking for students or maybe, let's say, employees who are capable of working on chatbots, employees who are capable of working on LLMs, LangChain, Llama Index, all right, and GPT-based architectures. So let's understand this. So in this section, we'll be essentially dealing with the brief of machine learning and deep learning as well. So those of you who are not familiar can get some idea. At least I'm hoping everyone is familiar with machine learning. Guys, I hope everyone is familiar with machine learning. Yes. All right. So over here, let's get this started. So see, large language models after mastering machine learning and these deep learning is a natural progression. Means, see, suppose you have covered up machine learning, you have understood the fundamental concepts of machine learning. So let's say you're on step one. The next step would be to understand the fundamentals and the applications of deep learning with practical implementation. That is going to be step two. Then the next step would be the attention models, the transformers model, and maybe let's say frameworks like or libraries like TensorFlow and PyTorch, right? That would be the step three. And the step four, as far as let's say if you're stepping up the ladder, then the step four is definitely going to be the LLMs and LangChain or maybe Llama Index, right? So let's say understanding LLMs is a natural progression after having covered machine learning and deep learning that allows you to leverage the foundational knowledge and skills from the machine learning and deep learning to tackle much more complex and specialized problems in the field of NLP and even multimodal architecture domain as well. All right. See, LLMs means as of now, when we're talking about specifically, let's say LangChain and maybe Llama Index, so we can concentrate mostly on text-based models, all right, that generate text as output. But we are already living in the era of multimodal architectures. Multimodal architecture means, let's say, anything can be converted to anything. So previously also we have discussed this concept and reiterate when we're talking about multimodal architecture, right? So when we're talking about multimodal architecture, we are talking about text, image, audio, GIF, all right, maybe video, all right, web page, JSON, table, any kind of data. We are talking about this is set as input. This is the input to the model. This is the data on which model has been trained upon. And what is the output? Output can be any of these. Output can be any of these. This is referred to as multimodal architecture. This is referred to as multimodal architecture. All right. Now, ChatGPT 3.5 is essentially, let's say, text to text. You feed in certain text, you get response as a text, maybe at times as a table, maybe at times as a JSON file, maybe at times as a HTML file, right? So this is the privilege that you end up getting with ChatGPT. But suppose you want to generate a diagram, you want to generate a flow chart utilizing ChatGPT. So that is where you need to upgrade to the pro version. So definitely you might have come across models, and previously also we have discussed in the master session. You might have come across Sora, right? So that is text to video architectures. So we do have audio to audio architectures, image to audio architectures, audio to video architecture. We have text to web page architecture, web page to text architecture. Means any of these can be input and any of these can be output. This is essentially what is referred to as multimodal architecture. All right. Now, these days, industries are more interested in integrating integrating, let's say, maybe text to text to, let's say, text to image, or maybe text to video. This is the kind of architecture, let's say, that as industries are heading towards. Means a single, let's say, model or a single application that is capable of performing all the three. And then, of course, since you do have the privilege for Q&A, you can perform Q&A on this kind of an application. So this is already into the picture, right? This is already into the picture. Next, we are trying to achieve this. And of course, means once this application is ready, we can implement Q&A on the same. All right, this is one particular application. There can be multiple different applications as well. You can generate an API, you can perform, you can implement REST API, you can implement GraphQL. So there are a number of other applications as well. All right. So I hope this is clear. So the objective over here is to leverage the foundational knowledge and skills from machine learning and deep learning to tackle much more complex, specialized problems in the field of NLP and let's say NLU, natural language generation. Now, let's understand the fundamentals of machine learning. So when we're talking about machine learning, right, we have learned the core concepts and algorithms, including the supervised and the unsupervised learning. Yes, I hope everyone over here is familiar with the supervised and unsupervised learning. So in supervised learning, we do have labeled data, and in unsupervised learning, we do have unlabeled data, right? We do have unlabeled data. Yes, all right. So, see, foundation of machine learning is crucial when dealing with LLMs, as it helps you to understand that these models are built, trained, and optimized, following the same routine, the same pattern, the way, let's say, ML and DL have been trained upon. Means there are a couple of advanced complex nuances involved, but essentially the learning process, the procedure remains the same, right? So how these models are built, trained, and optimized, concepts like supervised, unsupervised learning, loss functions, regularizations, they're essential when working with any kind of model, including LLMs. Are you getting this? Guys, I hope you are getting this. Okay. So suppose over here, I do have an example. I'll show you the image as well. So how ML models distinguish between, let's say, two genres of music. Suppose we have reggaeton and R&B. And in case we do have a linear classification. So this is just an example. So just try to concentrate over here. Based on, we have two different kinds of songs, right? We have R&B and let's say reggaeton. These are two different kinds of songs. And we are supposed to classify a song based on its energy and tempo. Based on its energy and tempo, we need to classify these two models, right? So essentially what we are doing, we are generating a linear model. This, let's say, straight line separates the two classes, the two different classes that we have based on their features like energy and tempo. So if at all we do get a new observation, the objective over here is to classify whether this song belongs to R&B song or is it a reggaeton song. Yes, this has been the sole objective as far as linear classification is concerned. Now, as of now, I've considered a binary classification model. We can go for even a multi-class classification model as well. Are you able to understand this image? Yes. So let's say machine learning is capable of generating this kind of a prediction. Means we can train the model maybe using a linear classifier, be it logistic, or we can even, let's say, implement non-linear classifiers as well, such as this is simply random forest. We can go for even boosting methods as well, right? Like XGBoost, DataBoost, Gradient Boost. And we can even go for, let's say, SVM night base as well. So this is just the case for linear classifier. Now, machine learning can also handle the case of non-linear classification. Yes, machine learning is also capable of handling non-linear classification. Can someone tell me which model can be utilized for the same? Which model can be utilized for non-linear classification? All right. Any other options other than KNN? Other than KNN, yes. Decision tree, definitely. Random forest, and let's say random forest, the evergreen model, or we can go for the XGBoost, right? SVM XGBoost. Definitely, they are capable of performing and generating better results when it comes to non-linear uh, data, right? So let's say machine learning models have been capable of working on both linear data and non-linear data. Clear? So the predictions we do end up getting is in form of a probability. Yes, and we need to predict whether the let's say data belongs to class 1 or class 2. Maybe class 1 is R&B song, class B is reggaeton song. The features being energy and tempo. I hope this is clear to everyone. Yes. Okay. Just a minute. Yeah. So now the question is why LLMs? Okay. So for machine learning, we have seen, right? So this is where this is the starting point where let's say we are training a model. And as of now, this is a machine learning model. So this is a very fundamental or a let's say a very rudimentary model, right? This is where let's say we need to scale it up to understand the concepts of deep learning. Now, what if data is neither linear, data is neither non-linear? We have this kind of a data. We have vectors in form of let's say suppose we have text-based data, right? We have text-based data and we need to process this data to generate predictions whether the sentiment is positive or negative. And the text-based data is not present in form of text. Rather, we do have something known as word embeddings. Word embeddings are basically the vector representation of the data, right? So over here, we do have vector representation of data. And just in case we wish to apply, let's say, a machine learning model even for word embeddings, so we can proceed with the same as well. And for that, let's say it is capable of predicting whether it is positive or negative. All right. But suppose now, as far as the word embeddings are concerned, so the size is not quite small. When we are talking about word embeddings, the size can go into thousands and even beyond for each word. All right. Each word will be represented in form of a vector, and similar words would have similar vectors because vectors comprises of context. All right. So we do end up getting some semantic and syntactic clarity about the words in form of vector embeddings. All right. So essentially, when the size of the data grows, ML models would, let's say, fail to perform well, especially when we're talking about this kind of a data, or maybe when we have images. Maybe when we have images, so machine learning models would not be able to, let's say, perform quite well compared to what we are, let's say, stepping up for. So next, after having, let's say, understood machine learning, next we have deep learning, right? So deep learning focuses on neural networks, which are the backbone of LLMs. So through deep learning, we can, let's say, gain a deep understanding of neural architectures like convolutional neural network, recurrent neural network, and let's say, uh, the starting point for LLMs, which is the transformers. All right. So having some understanding of deep learning will help you better understand the concepts of convolutional neural networks and RNNs. And if you can, let's say, upskill yourself to the level of transformers, that would be great because transformers are the starting point for LLMs. So transformers serve as the foundation for most modern LLMs. So suppose, let's say when the data grows large in size, especially these word embeddings, we have maybe lakhs and lakhs of, let's say, sentences for which we need to predict the sentiments for. And we may have, let's say, some sarcastic, let's say, text as well. And on top of it, we are generating a very large text embedding, word embedding. So this is where machine learning model might not be able to capture the, let's say, essence of the data that we are feeding into the model, right? So this is where, let's say, deep learning models comes into picture. So for, let's say, we can even work with image classification, text classification, and there are n number of couple of things that can be, let's say, implemented using deep learning. We can perform image segmentation, we can perform text clustering as well. So when we're talking about, let's say when the data no longer remains structured, right? When we have suppose image, we have audio, we have video, we need to implement some, let's say maybe sentiment analysis or image classifications. For these kind of applications, we need to have a neural network in the first place, right? This is the kind of structure that we may have for a neural network, and its architecture may vary depending upon the complexity of the data and the kind of task that we're dealing with. Guys, are you able to understand these concepts? Machine learning and deep learning stuff? Majority of you might be already familiar with these concepts, right? Okay. So let's say we are feeding in this image and we are training the model with n number of such images, maybe cats and dogs. So we may end up getting something like this. So this is a multi-class classification where we have three classes. We have cat, dog, and bird, right? So as you can see, these are the probabilities that we are getting. So this is how, let's say, neural network architectures are trained. This is how neural network architectures are trained. And if we wish to, let's say, predict the sentiment, then again, machine learning models, or rather, it's better to utilize deep learning models for such scenarios, right? Now, consider a deep learning model where, let's say, we are predicting the next word. Where we are predicting the next word, that is the example I'll be taking, let's say, to understand the LLMs and how after machine learning and deep learning, we are progressing towards the LLM. So LLMs, as discussed, let's say LLM training is the process of teaching LLM to understand and generate human language. This is achieved through feeding the model with massive amounts of text data or even text and image data in the case of multimodal architectures, and then utilizing algorithms to learn patterns and predict what comes next in a sentence. The resultant is an AI system that can generate human-like text, translate between languages, answer questions, and even perform many other cognitive tasks. All right, this has been the agenda so far. And this is what LLMs have been utilized to reach its fullest capacity. Now, let's try to understand this. So you have seen this image, right? So over here, clearly we can see cat is in the box. Now, suppose we are training, let's say, an LLM, right? Which is an extremely large neural network to begin with. And on the surface, this is what we are considering. The cat likes to sleep in the. So we need to predict the next word, right? We need to predict the next word. So see, there can be n number of words that can follow after the. So don't you think this is a classification task? Out of n number of words, we need to predict the most suitable word. Is it a classification task? Yes. So to implement this classification task, we are utilizing an LLM. Means if it's just one word or maybe couple of words, maybe just one sentence, then of course we can utilize deep learning. But the fact is we are not, let's say, we are not utilizing LLM just to generate one word or maybe one or two sentences. We are utilizing LLMs for all these tasks. All right. Like translation, summarization, question answering, and even perform other cognitive tasks. So this is where we need to have LLM in the first place. This is beyond the capability of the generic deep learning models. The generic LSTM, BiLSTM, and even BERT, and maybe some advanced versions of BERT even can't handle these kinds of responsibilities. All right. Means they can be scaled, and when it comes to scaling up, that is why we have LLM in the first place. So after that, there can be n number of words, right? So this is where, let's say, LLMs come into picture. So just have a look. So we can create vast amounts of sequences for training a language model. This is where we need to, let's say, train the model with large amount of data because we need to perform these kinds of tasks. So what are the tasks that we're dealing with? Translation, question answering, and let's say even, let's say, extracting a particular part of the text. Because when it comes to question answering, there can be any kind of questions, right? There can be any kind of questions as well. I hope this part is clear to everyone. Guys, just have a look. So over here, now it's not just, let's say, the next word that we are predicting, right? We do the same for much longer sequences. Are you getting this? We are doing the same for much longer sequences. And that is how in a larger context and the LLMs are trained. All right. So it's not just the next word. A trained language model can, let's say the next word is generate, and after generate, the next word is coherent. Means, see, suppose when the next word has been predicted, so the next word is again, let's say, fed to the model for training so as to generate the next word, the next to next word. A trained language model can, the next word prediction by the LLM is generate. And once the next word has been predicted, it is again fed to the model for training because now the sentences a trained language model can generate. And then it is capable of predicting the next word, which is coherent. This is where the feedback comes from. Are you getting this? So guys, if you're familiar with, let's say, LSTM or how the RNNs work, yeah, recording will be shared as discussed. Recording will be shared. See over here what we are doing. First, let's say the model is predicting the first word, which is generate. Trained language model can, the next word is generate. Now, once the generate word has been predicted, it is no longer part of the input sequence, right? This has just been the prediction. So this prediction added along with the original input is fed to the model again. So as to allow the model to train and predict the next to next word, which can be coherent. Are you getting this? See, this is the sentence. This is the kind of sentence that we're dealing with. A trained language model can generate coherent responses or maybe coherent text. Is it clear? Is it clear, guys? So this part is referred to as the self-supervised learning. This part of the, let's say, LLMs is referred to as the self-supervised learning. All right. So guys, now I understand, means I'm hoping that you might be having an understanding about how, let's say, we have started from ML, then let's say we have catered to the subtle nuances of deep learning, and on top of it, let's say at the pinnacle of it, we have the LLMs. Yes, I hope this part is clear. So guys, now let's set up the, we are going to set up the API queue for the OpenAI and Gemini. All right, so do one thing, just like this. Open Google and type this OpenAI API. Just like this. Then, okay, just open the first link. Means see, I'm not familiar whether your credit balance is zero or not. So first we'll check, and if it is zero, maybe you need to sign up with a different Gmail account. All right, open this link. Means I've already signed up, so you can click on sign up. Right over here, you can click on sign up. I've already signed up. Okay, just a minute. Yeah. So if you sign up, okay, let me just sign up over here. So guys, please complete the sign up and ping me once you have done. Once you are done. All right. So over here, go to your profile. Go to your profile. Go to your profile. Done. So in your profile section, you can come to the API keys. Means you can go to the pricing page. I'll show you. Now there's an option for billing, right? There is an option for billing. The my credit balance is showing zero. So there might be need to recharge it. To check, go to this page. Means you need to go to your profile, right? First of all, you come to your profile. Then in your profile, just directly come to the billing part. What is the number that you see over here? Is it zero? Okay. Just have a look. On Google, just type OpenAI pricing. Type OpenAI pricing. All right, just sign up over here. Yeah, take your time. So once you sign up, let me know. If you have signed up over here, let me know. See, sign up page it would be different. You need to log in. You just need to sign up. Just click on OpenAI API pricing. Click on the first link. Click on the first link and sign up. Over here, you find an option for sign up, right? You have to sign up using your Gmail account. All right. So once you sign up, are you able to? Is everyone on this page? Do you guys see this page? What about the remaining students? Guys, are you able to see this page? Please respond. All right. So assuming everyone, let's say, has come, means everyone has arrived on this page. Let's go to your profile. You can switch to your profile and go to the billing section. Go to the billing section. Now just check the balance over here. Check the balance over here. What is your balance? What about the remaining students? Guys, what is your balance? Zero. Everyone is getting zero. Okay, so you just need to log out from your Gmail account. Create a new Gmail account. Billing section. This is the billing section, right? Click on your profile. You have to click on your profile and then you can come to the billing section. Then you can come to the billing section. Zero, right? So means you need to sign out from your Gmail account. Log in with a different or unused Gmail account. Let's say that you have rarely used. Use a Gmail account which with which you have never used ChatGPT before. And if you're not able to recall, create a new Gmail account. Let's check this. See, till the previous master session, this was the case. See, okay, so this service it seems has stopped. Previously, this service was available. Just check. Sign up using a new Gmail account. Over here it says OpenAI no longer gives free credits to new account. Free credit tokens to API users on platform are only given first time when you sign up. Okay. Sign up with a new account. All right. All right. So let's validate whether we are in a position to, let's say, utilize this or not. Let's validate this. Now to validate this, what we can do means everyone is on this page, right? Everyone is on this page. All right. Do one thing. Just a minute. Guys, just a minute. I need to log in with a different account, right? Just give me a minute. I'm sharing the screen. I'm stopping the screen share for a minute. Just a minute. All right, guys, just have a look. So let's experiment this and check whether we are able to create the API or not. Means let's just check. Go to your profile. Go to user API keys. Go to user API keys. All right. Now over here, do you find this option of create new secret key? You find this option of create new secret key. The remaining students, can I get a response? Go to your profile, then you'll find this option of create API keys. So what you need to do, all right, you need to create a new secret key. You need to create a new secret key. Just copy it. You can simply copy it, all right? So over here, just to check whether it is working or not, we're simply going to check, let's say, whether this functionality is working or not, all right? So for that, over here, I'm writing. Okay, you need to import it as well. Let's do one thing. Open your Google Colab. Guys, open Google Colab. Connect to GPU. Open Google Colab and connect to GPU. See, don't close this window. See, when you create a new API key, right? Don't close the window. Means I do have this API key as well. So I think I've overconsumed it. Let's see. Okay, I'm calling this key as key 31st August. All right. So create the secret key. Now don't close this window before copying this. All right. So copy this. I've copied it. So this is my next step. Are you guys following along? Are you guys following along? All right. So over here, I've copied the API key, right? So this is my OpenAI API key. Means you might be having a different API key. So we are just validating whether it's working or not, all right? We're simply going to validate whether it's working or not. So over here, there are a couple of dependencies that I need to install. So just install OpenAI and LangChain. Install them. Connect to GPU, go to edit, notebook settings, and then T4 GPU. Means over here, I'm simply going to check whether I'm in a position to, let's say, utilize this. I'm simply checking whether we are in a position to utilize this version or not. Means we need to make the payment or not. All right. Is it clear? Guys, please respond. All right. So have you installed this? Proceed with the installation. You have to install these libraries, right? Okay, I'm sharing them in the chat. Okay, so I'll show you. So over here, as you can see, I've installed LangChain and OpenAI. Then, okay, you have to install this as well. Let's keep it simple. Get this installed as well. But install LangChain OpenAI. Copy your own API key. Copy your API key. And install LangChain OpenAI as well. API key is over here. All right. Over here, we will find the API key. These are the three dependencies that you need to install as of now. All right. These are the three dependencies that you need to install. Copy, see there's a clearly there over here, there's a button to copy, right? You click on create new secret key and then type the name and you'll get a button to copy it. Yes. These are the dependencies. I'm sharing it in the chat. Since I've already copied it. This is my API key, right? Once you've copied it, you can close it. Next, over here, we are just validating whether we can utilize it or not. Guys, is this part of the code? Have you executed this part of the code? All right. So next, and you have set up the API key as well, right? So over here, I'm directly passing the API key. So I can set it up as a can set it as an environment variable. That is not what I'm doing over here. I'm setting up directly over here. So we have defined this already, right? We have defined this already. This is OpenAI API key. See, I cannot share the API key. Rest everything I can share. This part I've already shared. Okay. Yes, this part I can share. This is the code you need to execute. And then over here, I'm just checking whether, let's say, it works or not. So over here, we are simply converting, we are translating English to French, all right? Or maybe English to Hindi. Right? Suppose this is the sentence. This is the sentence I wish to translate. Let me run this and then we'll see. Okay. So as of now, it's working. It's clearly able to translate, right? So if you have executed this part, the API key is working in my case. If you can check whether it's working in your case or not. Means this was just to check whether our API key is working or not. All right. How to enter the API key? See, once you have copied it from here, you just need to paste it, right? Once you have copied it from here, you just need to paste it. Have you fetched the API key? Have you fetched the API key? All right. Just paste it. See, over here I've created a variable. The variable is OpenAI API key. Paste your API key over here. All right. OpenAI API key. And then this is the code we have executed. So I've created, let's say, chat OpenAI instance, and which I've called it as LLM. The model that I'm utilizing is GPT-4o. Let's say there are a couple of other parameters for certain randomization. And this is the message. Let's say this is the sentence I wish to translate. So clearly, as of now, it's working. So if it's working, it means, let's say, SK is not defined. Where is SK? SK I've never used. Okay, maybe if this is not the case, then you can utilize model is equal to GPT, then 3.5. Try utilizing this. If 4.0 doesn't work, try utilizing GPT 3.5 Turbo. GPT 3.5 Turbo. Okay, this code, yes, sure. See, do one thing. As of now, just go through the code, right? See, because the pace at which I'll be implementing might not be the same as your pace. So it's better that as of now, you just, instead of, let's say, coding along with me, instead just focus on the code and just try to understand what is being explained, right? Means you need to create any variable. Over here, I've created a variable such as OpenAI API key. If GPT 4.4 4 is not supported, try utilizing GPT 3.5 Turbo. Means this is just a validation code just to check. See, I told you first you have to install this. First you have to install this. I've shared this code in the chat. I've shared this code in the chat. First you need to install OpenAI LangChain and LangChain OpenAI. So you need to use Colab. Are you using Colab? Okay, I'm sharing it again. So there might be some dependency issue. I'm sharing it again. Please install it. Guys, instead of code along, if you guys can just focus on the code and try to understand what is being explained, that would be better. Otherwise, it might consume a lot of time. Just validate whether this API key is working or not. That's it. Is it working? Is there anyone all right? What about the remaining students? Guys, is it working? I've shared the remaining code. Everything has been shared. You'll have to scroll through the chart. Okay, quota exceeded. So try logging in using another account. Try logging in using another account. So as of now, clearly you have seen how to create an API key. Yes. Now you have seen how to create an API key. Now, in case for those of you who are getting the error, previous start is there, no one is deleting it. You'll have to scroll up. See, you have to write it in double quotes. How have I written it? How can you API key just do 2 words? It's an entire string, right? It's a very long encrypted string. You'll have to copy the entire string, and it has to be in quotes. It is a string. It is a string variable. To use GPT 3.5, you have to write this. You have to write GPT hyphen 3.5 hyphen turbo. Sudeep, you have mentioned the API key incorrectly. All right, so either you can do the payment if needed. Otherwise, you can just, let's say, follow along. Means if you're not interested in payment, no issues. Maybe just follow along. You'll have a better understanding how we are implementing this. Maybe you can create a new Gmail account and then sign up into OpenAI using that Gmail account. For new Gmail account, at least I think one OpenAI API key you might be able to use for free. Is this done? Now, for those of you who have been able to successfully, let's say, implemented this, did you guys sign up with a new Gmail account? Did you guys sign up with a new Gmail account? Tarushri and Shubham, Suvitha, did you guys sign up with a new Gmail account? So guys, everyone please sign up with a new Gmail account. Only then you might be able to, let's say, implement this. Sign up with a new Gmail account, an account with which you have not utilized ChatGPT before, or maybe create a new account. All right. What is the error? Yes, rate limit error means you need to use a different Gmail account. Rate limit error means you need to use a different Gmail account. You can't utilize using the same, or you have to make the payment. The choice is yours. All right. So this was just an example to set up, let's say, LangChain and OpenAI. And as of now, for my system, let's say the API key is working, right? The API key is working. Alternatively, there's another option that we can explore. See what we can do. There's another option that you can proceed with. All right, let's say you can set up Google Gemini key, right? If you are not, let's say for those of you who are not able to set up OpenAI key, you can set up Google Gemini key. Now to access Google Gemini key, what we need to do? See over here, we are passing Google API key, right? Over here, we are entering the Google API key. Now where to fetch this Google API key from? Guys, let's understand where to fetch this Google API key from. So go to Google, go to Google and type Gemini API key. Go to Google and type Gemini API key. Of course, you need to sign up over here. So see, just check. Is there an API key pre-existing? Just check this. Please check, is there an API key pre-existing? Okay. Click on create API key. Click on create API key. Just maybe type something, maybe first project or something. Create API key in existing project. So over here, let's say it is creating a new API key, right? You can simply copy it. You can simply copy it. Guys, are you able to create the Google Gemini API key? Are you able to create the Gemini API key? Yes. All right. Now copy this API key. All right. I'll show you. This is when let me close these files. Now over here, this is my text Google API key, right? Guys, this is my API key. I've copied it over here, and then you need to install this. you need to install this. I'm sharing you this code. See, previously, we have installed LangChain OpenAI, right? So LangChain OpenAI was, let's say, utilized to establish connection between OpenAI API key and the LangChain. And likewise, we have LangChain Google API, LangChain Google Gemini, that is used to establish connection between LangChain and the Gemini API key. All right, so please proceed with this installation. Hopefully, here you won't end up getting the, let's say, the rate limit exceed error. Now, this is a different function that we're importing. All right, so over here I'm utilizing Gemini and API. So we will need to set up the environment or will it work? Let's see other params. Okay, I'll have to check the other params. Chat, Google generated AI. Okay. API key I'm passing this, all right? Means let me just implement this and then I'll share this code in the chat. All right, so as of now it's working. And then let's copy this. So I'll call this LLM2, all right? This is LLM2. Now this is some text message. This is LLM2.input message, AI message 2, and let's say, okay, let's translate this. Okay, this is my sentence. I wish to translate this sentence to French. All right, learning LangChain and LLMs after machine learning. Let's run this. So we are translating it into French. All right, as you can see, even this is working. So let's say those of you who are facing problems or who are facing rate limit issue, or maybe you need to create new account. So you can skip that part. You can use Google Gemini key, right? I've shown you how to create the Google Gemini key. This was the, let's say, OpenAI key, and this is the Gemini key. Have you created this? All right. Yes, sure. I'll share the code. This was the first part. Then this is the next part. I'm sharing the code. So over here you won't find rate limit error. All right. Over here you won't find rate limit error. Yeah. This is the code I've implemented. Please check and validate. Done. Guys, is this done? Please respond. I've defined it over here, right? This is LLM2. Over here, I've defined it as LLM2. Please avoid spelling mistakes. So means if you're using Gemini API key, you don't need to use. You don't need to, let's say, you can ignore the rate limit error issue, right? So instead of proceeding with OpenAI, you can proceed with Gemini API key. All right. So means this is just the first step. Over here, we are just setting up API key, and we are validating whether it's working or not. All right. We are validating whether it's working or not. So for ChatGPT, yes, you can try it in Jupyter Notebook as well, but you'll have to install the dependencies. You'll have to install the dependencies. You can try it in Jupyter as well. So guys, I hope this part is clear to everyone. How to generate and set up API key for OpenAI Gemini. See, it says you do not have access to it, right? So you need to make the payment. You need to make the payment, or what you can do, you can utilize GPT 3.5. You can utilize GPT 3.5, all right? Utilize this. Instead of writing GPT 4.0, just change it to this. Sarushri, you can change it. I've shared the code in the chat. Remove GPT 4.40 and utilize this. Is it clear? Is this part clear to everyone? All right. So guys, next we are proceeding with, let's understand the role of vector databases, right? Let's understand the role of vector database. So around for 15 more minutes, we'll have the theory part, around 15 to 20 minutes. Then we'll proceed with the practical implementation. All right, now to understand this concept of vector database, we have just seen one practical implementation, which is the word embeddings, right? See, any machine learning or deep learning model and even any LLM cannot accept string as input because of all the mathematical calculations involved. We cannot, let's say any model cannot accept string as input, right? So we need to convert strings into embeddings. And embeddings are essentially comprised of vectors. So this is where vectors come into picture. Are you getting this? When we're talking about vectors, word embedding, and vector database, let's understand this concept. Vector is essentially a list of numbers that represents data points in space. This is let's say this is a very fundamental definition of vector, but this is sufficient enough to understand or let's say uh, comprehend the role of vectors in embeddings, right? So for any string, for any text-based data that is not directly fed to any machine learning model, rather what we do, we convert the text into embeddings or vectors. Now in NLP, a word embedding is a vector that represents a word's meaning based on its context and usage in the large corpus of text. So if you guys are familiar with the LSTMs, and again, see, I will, okay, Tarushi, can you that just skip the part? Maybe you can log in with a different email account. You can log in with a different email account. All right. Just log in with a different Gmail account and use OpenAI API key. So over here, we are discussing about the word embeddings and the vector database. So in NLP, word embedding is simply a vector that represents a word's meaning based on its context and uses in the large corpus of text. So in context of LLMs, whenever let's say we are training a model to let's say to apply it in a chatbot, where maybe we are generating a chatbot, a conversational chatbot based on a PDF or maybe multiple PDFs, maybe based on uh, let's say some other corpus of text. So over there, what can be done? We need to store this large corpus of text, right? We need to store this large corpus of text in form of embeddings. All right. And this storage unit is referred to as the vector database. So in context of LLMs and natural language processing, these vectors typically represent the words, sentences, and even entire documents in form of embeddings. Are you getting the significance of the vector database or vectors in general? Suppose means maybe in another half an hour, we'll be creating a chatbot where we are training the chatbot based on certain PDF, right? So what is the objective over here? What is the objective of vector database? We need to store the content of the PDF in form of, the content will be available in form of words, right? We'll be converting the words into vectors and then we'll be storing the vectors into vector database. Are you getting this? So the words or the sentences present in the PDF will be stored as vectors in form of word embeddings into the vector database. So vector database is a specialized type of database designed to store, index, and retrieve high-dimensional vectors, which are mathematical representations of data points in continuous vector space. Guys, is the role of vector database clear to everyone? Is the role of vector database clear to everyone? Remaining students, can I get a response? See, it's not just about passing a sentence or multiple sentences. We are passing an entire PDF or maybe multiple PDF, an entire book. A PDF can be a book as well, right? So that is the amount of volume of data that will be feeding into the model. So we need to have a large corpus of word embeddings as well, and we need a storage unit. This is where vector database comes into picture. Now, there can be different types of vector database. Means we do have multiple options. We have ChromaDB, we have Pinecone, we have Fies. As of now, as far as this masterclass is concerned, we'll be using Fies because that is conveniently easy to use compared to Pinecone, because there we need to set up the account. All right. So vectors used in NLP, vectors are often used in NLP tasks, and they have hundreds or even thousands of dimensions. So as and when vectors grow into dimension, this is where, let's say, machine learning models would fail to scale. This is where the machine learning models would fail to scale up to that extent. And this is where, let's say, deep learning models come into picture. And when we are using, let's say, deep learning models for with word embeddings, now when the data size increases in size, so this is where LLMs has to come into picture. Are you getting this? With larger size of embeddings, first we step from machine learning to deep learning. With larger size of data, we are moving from deep learning to the LLMs. All right, so vector databases are optimized to handle these high dimensional vectors, supporting operations like nearest neighbor search, similarity search, and clustering. So all the vector database, they do support, let's say, similarity search. And this similarity search is based on context, semantic search, contextual search, syntactic search as well. We can also apply clustering as well. And let's say it also supports nearest neighbor search. So all the functionalities coupled with certain enhanced functionalities of LLMs, means all the, let's say, the previous functionalities that we are familiar with when it comes to machine learning, we are familiar with what is nearest neighbor, right? You guys have gone through the nearest neighbor algorithm. We are familiar with the concepts of clustering. So for those of you who have worked with, let's say, cosine similarity, you might be you might be slightly familiar with similarity search or cosine similarity. If you have worked with text clustering data over the recommendation system, so you might be slightly familiar with similarity search or maybe cosine similarity, right? So likewise, we have a much advanced level of similarity when it comes to vector databases. Over here, similarity is in terms of semantic, syntactic, contextual similarity. All right, so means after having, let's say, stored the embeddings in the vector database, we can apply functionalities related to similarity search. We can apply functionality related to clustering as well. Guys, is this clear to everyone? What is the role of vector database? Is it clear to everyone? Please respond. All right. Essentially, we'll be utilizing vector database to store the PDF data in form of word embeddings, right? First, we'll be reading a PDF. We'll be converting the PDF into chunks. All right, means we need to split the data into, let's say, into different characters. Then we need to store it in form of chunks. We'll be converting these chunks into embeddings, and then we'll be storing these embeddings into the vector database. Is this procedure clear? All right. Now, what is the role of vector database and LLM-based chatbots? So let's say the first and foremost, one of the most significant role for vector database that we have is efficient retrieval of relevant information. So vector database enables the chatbot to efficiently retrieve the most relevant information by comparing users' query. See, over here we do have a functionality for similarity search, right? So suppose we are searching for something. We write a query, we write a prompt, and based on that prompt, it will apply the similarity search between the user's prompt and the vector embeddings. All right, and the word embeddings that is stored into the vector database. So vector database enables the chatbot to efficiently retrieve the most relevant information by comparing the user's query vector with pre-stored vectors of potential answers or documents. All right, so they enable the semantic search where queries and stored data are compared based on the meaning, not just exact word matches. Are you getting this? Guys, are you getting this? All right. Next, let's say vector database also supports handling large scale data. So vector database are designed to scale efficiently, allowing chatbots to manage and search through millions or even billions of vectors in real time. All right. So the amount of data, let's say that we are handling over here, they can be of different data types. All right. And vector database also facilitates high speed, let's say similarity search. They facilitate high speed similarity search. All right. And instant responses when it comes to chatbots. Now we can also add a touch of personalization and contextual awareness. So let's say as far as personalization and contextual awareness is concerned, there are two key points that I would like to discuss: user profile and preferences. So chatbots can, let's say, they can store user profiles, they can store user preferences, and even the past data. Suppose you have interacted with ChatGPT maybe 3 times based on a particular context. So is it keeping track of the context as well? Yes or no? Is ChatGPT keeping track of the context as well? Yes. You ask five related question, maybe 2 to 3 questions, and then ask another question, maybe based on the first question. Is it able to track the context? So likewise, vector database, let's say when we are utilizing in chatbots, they can store user interaction preferences and history as vectors in form of vector database. So by comparing the current interaction vector with the stored vectors, the chatbot can generate maybe personalized responses based on previous interactions, right? Making the conversation more engaging. And it also keeps track of the context. All right. Besides storing the user profiles and preferences, it keeps track of the context. All right. And thus it is able to retrieve contextually appropriate responses from the data stored in the vector database. Because we need to track of the conversation flow as well, right? Conversation flow needs to be tracked as well. That is why, let's say, we do utilize some vector database. All right. And it supports complex query types. So vector database is not only meant, let's say, for PDF. Vector database is not just meant for PDF. It can support a variety of data types or in general, the multimodal architecture. So we can generate embeddings for different types of data, such as text, images, or even structured data like tables. These are some common examples. It can be scaled up for more complex data types as well. Is it clear? And there's another key point. Let's say I might have missed in the P2P. Vector database do support chain queries, right? They support chain queries and reasoning. Chain queries means, let's say, in machine learning, are you guys familiar with, let's say, chaining? Are you guys familiar with chaining in machine learning or even in pandas? So have you created pipelines? Are you guys familiar with the concept of pipelines? In pipelines, we are chaining, let's say, a particular n number of particular steps in a sequence, right? One after the another. Yes, that is referred to as chaining. We do have the concept of, let's say, chaining in pandas as well. All right. So vector database, they do support chain queries and reasoning as well. Right? We can chain multiple queries together so that let's say the response of one query can be fed as another query. Means the output generated maybe by ChatGPT. Suppose I wish to utilize the output as in form of another prompt. So that is when chaining comes into picture. Is it clear to everyone? All right. Guys, next, so we need to understand, we are going to understand a quite high level concept, which is referred to as RAG. All right. We are going to understand the concept of RAG. And again, before starting the RAG itself, so let's say we are discussing it on a surface level. We are going to discuss RAG on a surface level, right? All right. So let's understand this. So these days, let's say whenever you come across a chatbot, it is coupled with RAG. The chances are high that it is coupled with RAG, it is integrated with RAG, it is optimized to cater a particular or to handle a particular problem statement, right? So let's understand what is RAG. RAG stands for Retrieval Augmented Generation. RAG is Retrieval Augmented Generation, and as the name sounds, it is, let's say, comprised of three fundamental actions or three fundamental tasks in the first place. So we have this retrieval phase, then we have the augmentation phase, and then in the end, we have the generation phase. So RAG is a framework that enhances the performance of a large language model by integrating retrieval-based methods with generative capabilities. All right. So let's say this is the part where we are further optimizing the capabilities or enhancing the functionalities of LLMs to make it more robust and accurate. Are you getting the picture? We are trying to enhance the performance of LLM. Means RAG is completely different from the fine tuning part, right? That is an entirely different concept. And over here, we are optimizing the performance of the output that an LLM can potentially generate by utilizing the concept of RAG. So we are trying to integrate the retrieval-based methods with generative capabilities. So over here, the sole objective is to minimize the hallucinations. We have all witnessed and seen ChatGPT at times tends to falter, tends to hallucinate. Yes or no? ChatGPT tends to falter and hallucinate, right? Not every time, but let's say a couple of times. We have all experienced the same. So let's say when a chatbot is coupled with RAG, right? So this approach helps LLM provide more accurate and context-aware and relevant responses, especially when dealing with complex queries that require specific or up-to-date information. The objective over here is to prevent the, let's say, LLM from guesswork. We are restricting the LLM model to proceed with guesswork. We are not allowing the LLM model to make a guesswork for any query or some queries in general. Is the objective clear why we are utilizing RAG? So it acts as a bridge combining the creative responses generation of the models with the precision of retrieval-based methods. All right, so we'll be utilizing the precision of retrieval-based methods, ensuring that chatbots can source and integrate external information with far more accurate responses. All right. Is the concept clear for RAG? As in, to some extent, are you able to understand why we are using RAGs in the first place? Guys, can you please respond? What about others? The sole objective over here is to minimize the hallucinations. I'm not saying stop the hallucinations. All right. I'm not saying completely eliminate the hallucinations, but definitely minimize the hallucinations which we might face. That is where RAG comes into picture, right? So let's understand the, let's say, difference between a chatbot with RAG and a chatbot without RAG. So chatbots without RAG are limited to responding based on their pre-existing knowledge, which can lead to incorrect or hallucinated answers when faced with an unfamiliar question. That is what I've explained, right? See, there are three steps. First of all, it is going to retrieve the relevant information from the vector database. Then it is going to augment it with the element, let's say LLM responses, and then it is going to generate the corresponding responses. So these are the three steps. These are the three steps. So this retrieval part is based out of the vector database. Means it can be based out of the vector database. Retrieval means extraction. So this extraction is done utilizing the vector database. It's one of the approaches utilizing the vector database, right? Chatbots without RAG are limited to just responding based on their pre-existing knowledge, which can lead to incorrect or hallucinated answers when faced with unfamiliar questions. This means they might guess the answer, often resulting in hallucinated responses. And I'm hoping we have all seen ChatGPT falter at times. Yes or no? Guys, we have all witnessed ChatGPT falter, right? All right. Now, ChatGPT, chatbots, let's say enhanced with RAG, can access and use external information to answer the questions. All right. This capability allows them to provide more accurate and reliable responses, even for questions outside their initial training data. Are you able to grasp this concept? It means essentially we are trying to limit the guesswork when it comes to ChatGPT, right? You can ask any kind of questions. Yes, mostly any kind of questions are allowed, except maybe for certain, let's say, uh, genuinely prohibited questions. Otherwise, majority of the questions from any particular domain, as far as it is, let's say, positive questions, you can definitely ask in under a certain umbrella. Are you guys getting it? But at times, let's say, as you increase the complexity of the questions, there might be a situation where you may end up facing some guesswork type of answers, right? That is what we are trying to prevent when it comes to RAG. Now, the documentation itself means where else do you want to utilize it? It can be utilized at means there's a research paper, there's an entire research paper on the same. It can be utilized elsewhere as well, depending on the requirements. All right, now let's understand the three essential components of RAG. So we have this retrieval system. In RAG, we have the retrieval system, then we have the augmentation part, and this is the generation part. Sorry for the typo. So as far as the retrieval is concerned, this component searches large corpus of documents or a knowledge base to find the most relevant pieces of information based on the user's query. This is the retrieval part, right? So this retrieval method comes essentially out of the vector database, means we can set this up to the retrieval part. Now, the retrieval step usually employs methods like dense passage retrieval. All right, we have a concept called dense passage retrieval. You can go through the documentation. You can means in the documentation you won't find it. You'll find it in the, let's say, the paper, the research paper. In the research paper for R, you'll find this dense passage retrieval, or means we do have some other vector-based search algorithms that transform both the query and the documents into dense vectors and then find the nearest matches. So previously we have discussed about the similarity search. We have discussed about the similarity search, right? That is facilitated by, let's say, the vector databases. So even RAG is further optimizing the same. RAG is further optimizing the same, right? Next part is the augmentation. So the retrieved documents or snippets are then passed to the generative models, all right, as additional context or knowledge. Are you getting this? That first part is the retrieval. Second part is the augmentation. Augmentation is basically modifying modification of the existing answer, modification of the output generated by, let's say, the LLM models, right? And the third part is the generation. Ignore the typo. So the generated models such as LLM uses both the original user query and the retrieved context to produce a coherent and contextually accurate responses. Now, this component leverages the language model's ability to generate natural language text enhanced by specific information retrieved earlier. So whatever was retrieved earlier has been enhanced by RAG. Are you getting this concept? It's on the surface level, is it clear? All right. Before starting RAG itself, I mentioned, means I clearly stated that we'll be discussing RAG on a surface level. Means if you go through the research paper, there are n number of intricacies involved. There are n number of complexities that, let's say, that can further extend the conversation beyond, as of now, which is beyond the scope of this session. So there are n number of other things that we can, let's say, work upon and discuss when it comes to RAG. So essentially, we have discussed that there are three parts: retrieval, augmentation, and generation. Next, what are the advantages of RAG? So definitely, we do end up getting enhanced context awareness. Yes, guys, is it clear? Over here, we do get some enhanced context awareness. Then we also have improved accuracy, and we have dynamic knowledge integration, right? All right. Now let's understand this. Why learn chatbot building in 2024? So learning to build chatbots in 2024 offers numerous advantages due to increasing integration of AI-driven conversational systems across various industries. These days, every other, let's say, tech giant is into, let's say, conversational systems. Whether it is for clients, whether it is for users, whether it is for stakeholders, whether it is for some internal projects, everyone is dealing with these days. The tech giants are dealing with conversational systems. All right. So to explore why, let's say, of course, we have a widespread adoption and demand for the chatbots following AI-driven conversational systems. All right. Now, because of the advances in the AI and the NLP technologies, we need to, let's say, upgrade ourselves as well for future-proofing the careers to stay, let's say, adept with the AI technologies that we have at hand and the upcoming technologies. First of all, we need to understand LLMs and chatbot and how to, let's say, work with them. All right. So we can integrate them with the other technologies as well. We can integrate these, let's say, chatbots with other technologies as well, as in we can integrate them with IoT devices as well. We can integrate them with kiosk as well. All right. And if you have recently explored, let's say, carriers based on ML and DL, so majority of you might have come across chatbots and LLMs. These days, if you open, let's say, any, let's say, websites such as maybe Indeed, maybe Glassdoor, maybe Naukri.com, so you might have come across the terms chatbots, LLMs, LangChain, Llama Index. Yes. Have you explored opportunities in this domain? Or any ML or DL related opportunity have you explored during the past, maybe past 1 year, past, let's say, 3 to 4 months? Guys, have you explored opportunities in this domain? Please respond. Yes or no? If you have obtained, let's say, explored career opportunities outside of data analysis, let's say if you look forward to, let's say, join any organization as an ML engineer or maybe AI engineer, all right, or maybe some junior data scientist or these kind of profiles, definitely LangChain, Chatbot, Llama Index, these are the key priorities. These are the key priorities that one needs to get themselves familiar with. All right. Now, let's say we can automate as well when it comes to chatbots. Means we can integrate with some other technologies, and couple of tasks can be automated as far as conversations are concerned. All right. We can keep track of a number of conversations, and let's say a couple of things can be integrated and automated as well. So definitely it enhances the productivity. And of course, we need to understand chatbots and LLMs for future proofing carriers. Guys, I hope is this clear? Why we should learn chatbot building in 2024? If you explore any career opportunity related to machine learning and deep learning, especially let's say if it's a non-data analysis profile or even data analysis profile. So if you want to scale it further, you need to, if you're looking forward for a sustainable career option, definitely LangChain, LLMs, chatbots is a must-to-go option for. All right, guys, next we are directly proceeding with the chatbot building. All right, we are proceeding with the chatbot building. So please open up VS Code. Means if you're following along, maybe you can open VS Code. Okay, I've copied the API key, right? Over here, what I'm going to do. First of all, I'm going to create a virtual environment, all right? First of all, I'm going to create a virtual environment. So I'm assuming everyone has VS Code installed or at least can set up VS Code on their own. Yes, you guys have VS Code installed, right? You guys have VS Code installed. Please respond. All right. So over here, I'm going to first of all, I'm going to create a virtual environment. Over here, I'm going to create a virtual environment. So, guys, as you can see, this virtual environment is created. Now we'll be creating a folder. We are going to create a folder. First of all, we'll be activating the virtual environment. We'll be installing the dependencies. All right. Means I do have these dependencies installed. Otherwise, as well, it will work even without virtual environment when it comes to, let's say, the configuration that I have. All right, but let's install. Okay. So first of all, over here, I'm creating. Right, I'm calling it LLM chatbot. I've created a folder called LLM chatbot. Now I'm going to activate the virtual environment. All right. So guys, as you can see, this is how we can activate the virtual environment. As far as this virtual environment is concerned, over here there's a scripts folder. Inside the scripts folder, we need to activate this activate.bat. We need to activate this bat file. Is it clear? So clearly you can see we are inside the virtual environment. Now I've created this LLM chatbot, right? Let's go to this folder. Right now I'm inside this folder. Now over here I'm creating, let's say, PDF chart.py. I'm creating a file called PDF chart.py, and I'm also creating another file which is requirements.txt. Right, guys, over here I'm creating a file called requirements.txt. This is where we are going to install all the dependencies. All right, this is where we'll be installing all the needful dependencies. Is it clear? Are you guys coding along, or are you guys just following? Can I get a response? Guys, please be responsive. Means I'm asking, are you guys coding along with me, or are you guys following along with the session? See, what are the dependencies required? First of all, I need Streamlit, right? First of all, I need Streamlit. Then I need LangChain. All right, because we'll be working with SQL as well. All right, I need Py PDF tool. So this is required to read data from the PDF. Then I need PIS, which is Facebook AI similarity search. This is the vector store. And some importing couple of libraries. LangChain experimental, then LangChain community. Okay, LangChain OpenAI, LangChain code. Then I might need PyMySQL. I'm installing the dependencies for all right. Okay. PyMySQL. Then I might be needing MySQL connector. All right. MySQL connector Python. And then let's see. All right. That should be enough. All right. Yeah, you can mention the versions as well. If required, you can mention the versions as well. At times, that is the sole reason we are in the virtual environment, right? So that there is no dependency conflict from any pre-installed library that I might be having. That is why I'm creating virtual environment in the first place, and I'll be installing all these dependencies. Clearly, you can see the virtual environment is activated. So I'll be installing all these dependencies once I write this down. So over here, I have streamed it in LangChain, PyPDF2, files, then LangChain experimental, LangChain community, LangChain, okay, see, this is spelling mistake, LangChain OpenAI, then LangChain core, PyMySQL, MySQL connector, Python. All right, and all right, that should be it. LangChain is there, yes. So clearly, as you can see, we are over here, and this is where I do have the requirements. So click install requirements.txt. Just a minute, just a minute, guys. Am I missing any requirement? Okay, I didn't know. I haven't saved it. I haven't saved it. Requirements.txt. We are in the masterclass 31st August, right? This is the folder, and I'm outside this folder, right? Requirements.txt. Seems correct. Let's see. Yeah, see, it is getting installed. Let's wait. Meanwhile, and this is where we'll be creating the chat with PDF app, right? So meanwhile, let me write the dependencies that I need over here. All right. So over here, let's say this will be the application, but over here, creating another file. which is, let's call it, I'm storing the vectors over here, right? I'm storing the vectors over here. So I'm calling it vector.py. Let's wait for the time being while it is getting installed. Over here, I need to write from LangChain community, I need to include means I can use the PyPDF too as well. Then from langchain.textletter, from langchain.textletter, I'm importing recursive character text letter. All right, we'll check for the spellings and from LangChain community, vector source. Over here, I'm importing files. All right, and from LangChain OpenAI, over here, I'm importing OpenAI embeddings. All right. So guys, over here, I'm creating, let's say, a file path, right? I'm creating a folder where, let's say, the document will be stored in form of the embeddings. Are you getting this? Let's call it vector store, and then DB files. This is where, let's say, the vector embeddings will be stored. All right, now I need to load a PDF. All right, so as you can see, the dependencies are installed, right? Now, over here, I do have these files. I do have these, let's say, PDFs, right? I do have this astrology PDF, then budget PDF. So as of now, let's say I'm utilizing. Okay, let me move these files to this folder. These are the PDFs, means these are the PDF that we can work upon, all right? So over here, I'm writing a loader, and loader is going to be PyPDF. PyPDF loader, over here, I'm, let's say, going for India budget, all right? This is India budget 2024.pdf. All right, and then as far as the docs are concerned, over here, I'll be passing loader.load. Then I'll use the text letter. So that the text splitter that I'm going to use over here is the recursive character text splitter. All right. And I'm passing the chunk size. Chunk size is 1000 and chunk overlap. That means let me write the code and then I'll explain it as well. The chunk overlap that I'm considering is 200. Then splits. Over here, I'm setting up the splits. Text splitter dot split documents. Because it is an object of recursive character splitter, that is why I'm in a position to apply the splitter, apply the split documents functionality over here. All right. So this is a document where it is loaded in form of the PDF file. This is the object of text splitter, and using the text splitter, I'm splitting the document into a chunk size of 1,000 with a chunk overlap of 200. Means the 200 characters from the previous document will have an overlapping with the next 200, let's say, characters of the next document. All right. So that there is some contextual, let's say, similarity available. Are you getting this? Then over here, I'm setting up the vector store. All right, and this vector store is going to be files dot from documents. So what is the document that I wish to pass? Over here, the documents is going to be splits. All right. And embedding over here, I need to set up the embedding. So let me set up the embeddings over here. Let's say I'm calling it LLM. And in LLM, I'm passing this OpenAI embedding. All right, now I need to check the API key, right? What was my API key? The API key I copied over here. Yes, this is my API key. So guys, this is my API key. All right, this is the API key that I'm using. And in OpenAI embeddings, over here, I need to set the API key. So this is just the first step. This is just the first step. All right. Okay, I'll explain this one. So there are a couple of other things. Then we need to apply vector store dot save local. Right, and I'm storing it over in this file. This is where I'm storing it. Okay, so just have a look. So see over here, first I've set up the API key. I've created an instance of OpenAI embeddings by setting up this OpenAI API key. I've created a path, db5 path that will, let's say, which will be used to store the vector embeddings. Then I'm reading this PDF file using PyPDF loader, and then I'm using the load function to load the file, and then using a recursive character splitter into a chunk size of 1,000 with a chunk overlap of 200. I'm splitting this data into docs, into different docs, right? And from this doc, I'm creating the embeddings, and FICE is converting these documents into embeddings. All right, and it is saving it into this file, db files path. Is this clear to everyone? Guys, is it clear to everyone what we are doing over here? So this vector, okay. So let's run this. Over here, I'm going to LLM chatbot. I hope there's no spelling mistake. All right, let's run this. So see, I've predefined the, let's say, PDF which I'm using. We can also create maybe browse option in the front end using Streamlit to upload a PDF file as well, right? So over here, I'm writing Python vector.py. So this should create a vector store path. Okay, pip install. Okay. Let's wait. Yes, over here I need to pass the embeddings. Yeah, I missed this, and this is going to be the LLM. That's it. And we have set up the API key. So the files vector store that we are storing is based on the OpenAI embeddings. Yeah, the code file will be shared. Means I'll be uploading all the files in the drive link, and the drive link will be shared. Towards the end of the session, the drive link will be shared. So this is just one part where I've created the vector store for the this PDF, right? So as you can see, there's a vector store created. The vector store and DB files. This is where I'll be fetching all this information from. So it generates the pickle index file and index files file. So as you can see, this folder means I've created using this code. All right. First, I'm reading the PDF, I'm loading it, then I'm splitting the data using recursive character splitter, and I'm splitting it into multiple docs. And then from the files document, I'm creating for these documents, I'm creating a word embeddings and storing it in the vector store folder over here. So I hope this part is clear to everyone. Next, in the PDF chart, all right, okay, let's, these dependencies anyway, we'll be needing them. All right, we also need this part. We also need this part, all right. So this was just the first part. This was just the first part. So we have PDF loader, then we have recursive text character splitter, then we have files, then we have OpenAI embeddings. So I need a couple of other things. Then from langchain dot prompts, from langchain prompts, import chart prompt template. Okay, chart, I just need chart prompt template. Okay, no issues. Let's import this as well. I need chart prompt template, and I need to import Streamlit. Import Streamlit as ST. All right. Then I need existing output parser. So these are a couple of dependencies that let's say might seem quite let's say unnecessary, but let's say as far as the chaining part is concerned, to chain let's say the rack part, we need to utilize them. All right. So over here, I'm setting up the output parser. I'll explain the code. Let me just write it once. Next, I'll show you the documentation as well. From LangChain code output, I think it is parsers. And then from output parsers, I need to import string output parser. And then I need to import runnable through. From LangChain codes dot runnables, I need to import runnable pass through. All right, see, these are the dependencies required. I might not be using a couple of them, but over here I've written these dependencies, right? So as you can see, first of all, see, I've created this vector store where I have means splitted the data into chunks and then stored it in form of, let's say, vectors or word embeddings, right? Now, this is my OpenAI API key. I'll be writing this code in form of functions. So first of all, I need to load the data. All right, I need to load my data. So where do we have this data? So we have this data in form of the vector store, right? So over here, let's say I'm creating OpenAI embeddings. Then API key is going to be this OpenAI API key. All right, and then DB files path. What is the path that I'm utilizing? Path is the same. We do have the same path. All right, this is where the data is stored in form of word embeddings or in vectors after being splitted. And then see, in the previous file I've stored, over here I've stored it. All right, over here I'm saving it, and then over here I need to let's say load it. All right, we need to load it. So files dot load local. All right, and in load local, over here I'm passing DP files path. All right, we need to pass this, then embeddings. All right, so this is what it will capture as far as the embeddings is concerned. And then let's say to prevent some errors, over here I'm passing allow dangers deserialization true. Deserialization is, let's say, over here we have a pickle file, right? So we need to unpickle it. So we might end up encountering some errors. To overcome those, over here I've set up allow dangerous deserializations. So this is the first part where we are loading the data. Means we have stored the data in vector in word embeddings in form of a vector store. And using this function, I'm loading the data. All right. So now my vector store is available to be utilized. Then let's define some prompt. So see, even the prompt, I'm passing it as a string. All right. So let's define my prompt. So how should I define the prompt? All right. So let's say you need to answer the question. You need to answer the question in the sentence as same as in the PDF content. All right. This is the general prompt that I'm passing. Is it clear? So, okay, let's consider it's going to be a multi-line string, right? Then over here, I'm passing given below is the context and question of the user. Okay, so the sentence closes. I need to pass the context. This is the context. Next, I need to pass the question. This is the question. So, see, additionally, we need to pass the context and the question. So, context will be fed from this data. Context is going to, what is going to be the context? Over here, I'm just passing a prompt, right? What is the prompt? You need to answer the question in the sentence as same as in the PDF content. Is the prompt clear? Guys, is the prompt clear? You need to answer the question in the sentence as same as in the PDF content. All right. So what is the context over here? Context would be my vector store embeddings, right? And the question would be the user prompt. The question would be the user prompt. Are you getting this? So see, this does not end over here. Let's say if the answer is not in the PDF, means I'm customizing the prompt. All right, answer. All right. Over here, what is my response? Means this is meant to prevent the guesswork. This is meant to prevent the guesswork. If the answer is not in the PDF, then how am I supposed to answer it? I can't answer this based on my training. Is this clear to everyone? Guys, this is going to be my prompt. Now, the question would be the user prompt. Let's say in the when I'll be creating the Streamlit application, which we're already creating, and the context is going to be the data stored in the PDF. All right. This is what, let's say, retriever is going to utilize. Then over here, I'm setting the prompt, and the prompt is chat prompt template. All right. And then from template. And what is the template that I'm setting over here? The template is going to be prompt. All right. And we are simply returning the prompt. So just have a look. You need to answer the question in the sentence as same as in the PDF content given below. Is the context and question of the user. I hope guys this part is clear to everyone. Please respond. Guys, is this part clear to everyone? Okay, then I'll be creating two more functions. Next, I'm creating, let's say, load LLM. All right, and in load LLM, let's say, I just need to instantiate OpenAI embeddings, right? I need to instantiate the chart OpenAI. Chart OpenAI, I did not, just a minute, from LangChain dot OpenAI, from LangChain into OpenAI into chat OpenAI. This is what I need to copy over here. All right. So over here, I'm utilizing model is GPT 3.5 Turbo. So this is going to be my LLM, right? This is the LLM that I'm utilizing. Means there are a couple of other parameters. So this temperature is used to set certain randomization. And what is the API key? The API key that I'm using over here is this OpenAI API key. All right. Then I can simply return this LLM. So load LLM chat OpenAI. This is my model, and temperature is 0. API OpenAI key. API key is OpenAI API key. Then over here, I'm going to use a function called format docs. Format docs, what it is going to do, it is going to accept certain docs and then simply return. Means, okay, I'm giving, let's say, a few lines of space, all right, and then join. Maybe one if required, we can give 2 lines of space. All right, then over here, I'm passing doc.page. This is how I'm utilizing. Over here, I've utilized a for loop, all right. So each and every content in the PDF, I'll be formatting it like this with 1 line space, all right. Maybe you want to give 2 to 3 lines of space. See, this is going to be the primary prompt based on which my entire query will be based upon. Whatever user types the question, suppose this is my PDF, right? This is India budget. Suppose the user asks some question about the this PDF. So the root prompt or the main prompt that essentially guides the output is this. All right. So over here, I'm asking the ChatGPT 3.5 Turbo model to provide me answer in the sentence, same as in the PDF content. Provide me answer in the sentence, just the same as the PDF content. So what is the PDF content? So over here, I'm passing the context. And what is the question that the user will be typing in the web app? Okay, question is going to be fetched from whatever the user types in the web app. Context is this vector store. Context is this vector store which I'll be formatting, like this. Are you getting this? Are you getting this, Abhishek? All right. So, guys, this part we have set up, right? So, as just have a look over here, we have set up load data, then load prompt, then load LLM, and then format docs. All these parts are set up. Next, I'm going to create the Streamlit application, right? So over here, I'm writing streamlit.header, means I'm not customizing it as of now. And over here, I'm writing welcome to PDF, let's say LLM PDF chatbot. All right. Then over here, let's say I'm setting my data, or let's say knowledge store. What is my knowledge store? So my knowledge store is this load data, right? This is where I stored my knowledge store. Then what is my LLM? My LLM is load LLM. See, I've defined it in form of functions and then I'll be chaining them. So to chain them, I'm creating, let's say, variables. All right. And what is going to be my prompt? My prompt is this load prompt. That is why I've created three functions. Load data, where my knowledge base is stored. Then load prompt, where I do have my prompt. So I'm trying to integrate everything over here. I'll show you the format as well. So over here, we utilize something known as LCEL. All right. Okay. So let me just write this and I'll explain what LCEL is all about. Okay, let me show you in fact. Yeah. So over here, if you go to, I'm just going to LangChain, all right? Just open LangChain, LangChain documentation, not this one. I need this one. So over here, just have a look. We have n number of components in the LangChain, right? Over here, we have n number of components. We have LangGraph, we have integrations, we have LangChain, we have LangGraph, and then we have LangSmith. Now, essentially, this has come across as a very effective, let's say, framework, integrating multiple packages, even for deployment as well, even for deployment and monitoring as well. All right. Now, to understand certain basic concepts, over here we can go to build a chatbot. All right. And over here, let's say it is guiding us to create a chatbot and show you the LCEL. Just a minute. Is it mentioned over here? Okay. Tutorials. Yeah. Over here, build a simple LLM application with LCEL. All right. See, LCEL stands for LangChain Expression Language. Over here, following the Pythonic syntax, LangChain has come up with LangChain Essential Language where we can chain multiple components. All right. So over here, as you can see, we have created a couple of components, right? We have the knowledge store, we have the LLM, we have the prompt. So we need to chain it in form of context. Means first we need to pass the context. And what is going to be the context? Context we need to, let's say, retrieve. All right. Over here, we need to retrieve the context. And from this load data, and then we have to format it. Over here we need to format it as well. Are you getting this? Guys, are you getting this? Please respond. Okay, so let me show you what I was saying essentially. Then over here I'm writing the query. Query is basically your question, right? See, over here we have two parts, context and the question. So the question part is going to be the query. The question part is going to be your query. All right, so over here I need to write streamlit dot text input. Over here, I'm passing a text input, and then over here, I'm writing enter your question. Enter your question. Okay, let me just write, I'll explain. I'll come to the explanation part. Let me just write this. So over here, clearly you can see four components. We have the knowledge store where we have the entire vector, let's say database. Then LLM. All right, this is the model. So we are utilizing ChatGPT 3.5 model. Then this is the prompt. All right, this is the prompt on which our question will be, let's say, configured. And out of this prompt, the question is the query part. Are you getting this? So if user has entered a query, if the user has entered certain query, all right, then first of all, I need to apply certain similarity search. Similarity search based on what? I need to search the query with bias vector data store, right? And then over here, we'll be generating the retrieval object. Over here, we'll be generating the retriever object. So in similarity search over here, I'm going to write what is my knowledge store? This is going to be my knowledge store, right? And from the knowledge store, I'm applying similarity search. And I'll be applying the similarity search on what? I'll be applying similarity search on the query. Means the knowledge store will be searched for similarity against the user query, right? Are you getting this? Okay, over here I've named it similarity search. Let's call it similarity embedding. I'm calling it similarity embeddings. All right, and then let's say in the similarity embeddings, over here I'm writing files dot from document, and what documents do I need to look into? Over here, I need to look into similarity embeddings. All right, and what is going to be my embedding? My embedding is going to be OpenAI embedding, which I think this one. Guys, let me just complete and then I'll come to the explanation part. See, from the files vector store over here, means I'm passing, this is the, let's say, similarity embeddings. All right, and this will be the data which will be fetched. This is the data which will be fetched based on this OpenAI embeddings. All right, then because I need to create a retriever object, I need to create a retriever object to implement RAG. So I'll show you. I'll show you where the LCEL part comes into picture. LCEL. All right. We have just seen this LangChain expression language. So it is a typical kind of a syntax. All right. I'll show you the documentation as well, how we are implementing this. Means it is very much similar, but it's not exactly the same code, because there you'll find a different example in the documentation. Over here, I'm utilizing a different example, right? So as far as the retriever is concerned, so this is similarity embeddings dot as retriever. All right. So this is the RAG part. This part that I'm using over here is the RAG part. All right. This is the retrieval part. This is the retrieval part. All right. And then next we need to chain. Now, when we talk about the chaining part, this is where the LangChain expression language comes into picture. Over here, we need to define the RAG chain, right? This is going to be my RAG chain. Means, and the chaining syntax which I'm using, this is going to be the LCEL. LCEL, let's say, syntax. Now, whatever I'm writing next is going to be the LCEL syntax. So first, over here, I'm passing a tuple. In tuple, the first element is going to be the dictionary, in which I need to set up the context. All right, and the context is going to be retriever. All right, and then I'll chain it based on the format docs. I'll chain it based on the format docs. So the pipeline operator is meant for chaining. All right, and they're all instances of runnables. I'll show you what runnable means. Then I need to pass the question. All right, and question is going to be fetched through runnable pass through. Question is going to be handled using the runnable pass through. So this is just the first part. All right, and next, so over here I've set up the dictionary. Then I need to chain it with, prompt. Then I need to chain it with LLM, and whatever output it generates, right? Whatever output it generates, I'll be chaining it with string output parser to extract the relevant string information out of the output. All right, now this is referred to as a typical LangChain, which is written in form of LangChain expression language. This is written in form of LangChain expression language. And what is going to be my response? The response is RAG chain, and then over here I'll pass query. Over here I'm passing the query, and then streamlit dot write. I'll pass the response. All right, guys, this is my code. Let me check for any let's say errors. So welcome to LLM PDF chatbot. This is my knowledge store, and then knowledge store dot similarity search. I'm applying the similarity search on the query, which the user passes through the text input. Then I'm storing the similarity embeddings, and I'm applying files from documents, document similarity embeddings, and the embedding is going to be uh, OpenAI embeddings. The retriever is similarity embeddings dot as retriever. All right, so this is where the retrieval part happens when it comes to RAG, and this is the RAG chain. Augmentation and generation, they're all part of this RAG chain. So context, okay, see, this is spelling mistake. So context is going to be retriever, then whatever is retrieved, I'm formatting the docs. And what is the question? The question I'm setting up through runnable pass-through that takes this query, right? The runnable pass-through takes this query, and then we are passing the prompt and then LLM. So this is the part of the chain. This is the part of the RAG chain. Whatever is generated as the output, let's say, extracting the string output from it, and this is going to be the response. So over here, it need to takes the query. This RAG chain has to take in the query. All right. So okay, now let me show you the documentation. Let's understand this with the documentation. So over here, build a simple LLM with LCEL. Prompt template for chaining it together with C. This is the chaining part, and that is an output of LCEL. Let me show you the tutorial. We have, yeah, see over here, build a retrieval RAG application, right? Over here, there's a link to RAG application. Let's see this. RAG, as discussed, is a technique for augmenting LLM knowledge with additional data. So LLM can reason about wide-ranging topics, but the knowledge is limited to the public data up to a specific point in time that they were trained on. This is what we have discussed. So if you want to build an AI applications that can reason about private data or data introduced after the model's cutoff date, all right, we need to, let's say, integrate RAG along with the specific model. So the objective over here is to the process of bringing appropriate information and inserting into the model prompt is referred to as RAG. Now, so first of all, what have we done? We have loaded the data, we have splitted the data, we have embedded it into vector embeddings, and now we do have a vector store. This part clearly we have implemented. This is the part we have implemented over here. Guys, please respond. I hope this part is clear to everyone. I hope this part is clear to everyone. Yes. Now, after this part, what is the next part? So loading, splitting, embedding, and storing is done. So as far as RAG is concerned, given a user input, relevant splits are retrieved from storage using a retriever. This is where I've created the retriever object. So whatever is the user question, it is fetching, it is retrieving the desired information from the vector store, and let's say adding it to the prompt, passing it to LLM, and then generating the output. All right. So this part we have already set up. Langsmith as of now is not required. See, these are the dependencies. Over here, it is utilizing, let's say, a blog link. This is the blog link from where it is utilized. Means this is not the same code as what I've done. Even over here, we are utilizing recursive character splitter. We are splitting it into documents. Over here for vector store, instead of files, they have used chroma. So this is where, let's say, see, this is the chaining part. This is the formatting part. We have also implemented this in the same format. Okay, so they have utilized, let's say, 2 lines of space. Okay, even we can modify this to 2 lines of space. All right. So this part is done. Then just observe the RAG chain. Observe the RAG chain. Is it similar to what we have done? Is it similar to what we have done? Observe this. Context is retrieval. Then whatever is the context retrieved, we are formatting it. Means see there when we're talking about vector store data, so the data is in form of embeddings, right? Data is in form of embeddings. So we are simply formatting it by giving 2 lines of space. This is just 2 lines of space for every page of the content. And then question will be fetched through runnable pass through. Means when we are running it, what is the question? The question is what is task decomposition? This is what is fetched over here. This is what goes to the query. All right. Then this question, this context and the question, this context and question goes to this prompt. Now in this prompt is comprised of both the context and the question. All right. And then this, let's say context and the context question along with the prompt goes to the LLM. And then whatever is the output generated after utilizing invoke, I'm just extracting the string output parser from it. I'm extracting only its string part. So let's understand this. Let's understand this part of it. So over here, initially they are passing the indexing part, indexing split, okay. Then indexing to, then we have this. Yeah, just observe this part. What is prompt hub pull? Now this is a, let's say, predefined prompt, right? They have not created a custom prompt the way I have created. They do have a predefined prompt. Observe the prompt. Do they have the question and the context? Do you find a question and a context in the predefined prompt? Guys, there is a question and a context in the predefined prompt, yes or no? Over here, have we set up a question and a context? Over here in the prompt that we have set up a question and a context, right? So the context is the retriever, as in whatever is the information retrieved after scanning the, it's after extracting the similarity. After extracting the similar information, we are formatting it as well, all right? So this is the pipeline operator which is meant to chain. First, we are chaining context with the formatted document. Essentially, we are formatting the retrieved information. Then question will be fetched from the query. All right. This runnable pass-through means whatever we are passing as the query. Means when you call this RAG chain, so whatever you'll be passing as the query will be utilized in the runnable pass-through. So they're all instances of runnable pass-through. Means there are a couple of functions, means like invoke, that we can implement utilizing all of them. I'll show you. Just have a look. So when we use LCEL runnable protocol to define the chain that allows us to pipe together components and functions in a transparent way, automatically trace our chain in the Langsmith. So it means, let's say in Langsmith, we can visualize this chain as well, all right? Get streaming, async, and batch falling out of the box. So let's try to decipher this part of the code. See, each of the components retriever prompt LLM, they are all instances of runnable, means they implement same methods such as, let's say, sync, async, invoke, stream, batch, all right, which makes them easier to connect. They can be connected into another, let's say, runnable via the pipeline operator. LangChain will automatically cast certain objects to runnables when met with the pipeline operator. All right, format docs is to cast runnable lambda, means we are converting it to a particular format. That is how and why we are using the format docs. All right. Now, as we have seen, the input to the prompt is expected via dictionary with keys. We need to pass the context and the question. So first element of the chain gives runnables that will calculate both of these from the input questions. Are you getting this? So whatever is retrieved is formatted, and then it passes the question through the retriever, generating document object, and then format docs to generate the strings. Format docs is essentially required to generate the string output, right? Then runnable pass through passes the input question unchanged. So whatever is the input question, right? What is the input question over here? The input question is what is cache decomposition? And this is passed as the runnable pass through. Are you getting this? So chain invoke would build a formatted prompt ready for inference. And the last step of the chain are LLM, which runs the inference, and string output parser, which just plugs the string content out of the LLM's output. So that is how RAG is embedded or incorporated in the LLM. Are you getting this? Guys, this is the same part we have implemented over here. Now let's run this to check, and I'll show you the PDF as well. So India budget PDF, right? I think I've opened it. Yeah, this is the PDF. This is the PDF and it's in Hindi and English both. Means left side it's Hindi and right side it's English. So let's run this up first. Let's see if there are any errors that we might have overlooked. As of now, it seems correct. Let's run this. Over here, I need to first streamlet run pdf chart.py. And clearly, as you can see, we are in a virtual environment. So guys, first let's scan the document, all right? Let's scan this document. Okay, this is the budget, all right? Suppose I want to ask fiscal deficit is difference between total expenditure and revenue receipts. My first question is what is fiscal deficit? Okay, I think I'm getting some errors. Similarities, right? Over here, okay, this function over here is emitting error. Similarity search. Over here, I've used load data. So the data is loaded over here. And I'm applying similarity search on the query, right? I'm applying similarity search on the query. Similarity search. What went wrong? Is just give me a minute. Let me debug this issue. String output parser enable pass through. This is the OpenAI API key embeddings. Then the vector store, the pass embedding about dangerous serialization. I can't answer this based on my training. And then chat from chat template prompt, and then over here we are utilizing chat. OpenAI model is GPT 3.5 turbo, temperature 0, API key, LLM, and then we are joining it with i.page content for I inbox. Then my knowledge store is the load data, right? So if I do get a query, if the user enters a query, then I should get similarity embeddings by knowledge store. This is knowledge store similarity search on the query. Then similarity embeddings files.com documents. Document is okay. I need to pass this. It is the same thing. Similarity embeddings and embedding is OpenAI embeddings API key. Retriever is similarity embeddings as a retriever. Reaction this seems correct. Then in the context, I'm passing a retriever format docs. Question is runnable pass through prompt LLM string output parser. The response lag chain. Okay, I forgot the invoke function. I forgot the invoke function query of let's run this. Non type object has no similarity search. Knowledge store. Okay. Knowledge store load data. What went wrong? Non type object has no similarity search. Let's check this. Means I do have a I do have another application with almost the same code. If it fails, I'll show you that. Where is it feeling exactly? Line 88, sequential function, similarity embeddings, knowledge store dot similarity search query. Right, so somehow it's failing to extract the similarity embeddings, right? It's failing to extract the similarity embeddings. So over here, first similarity search, document the similarity embeddings, and the embedding is OpenAI embeddings, similarity embeddings, knowledge store. Okay, let's check the vector database part of it. So this is the OpenAI API key, the OpenAI embeddings loader is PyPDF loader, India budget 2024.pdf. Alright, then loader, load, then recursive, character splitter, chunk size is 1000, and the chunk overlap is 200. Then as far as the split is concerned, text splitter split documents, docs, then the vector store files from documents, and document is splits, and embedding is LLM. The embedding is LLM, which is this, and vector store.save local db files path. So then this seems correct. Why knowledge store is not able to fetch the information, similarity search. Okay. Guys, I'm passing the embeddings, and then we need to see these are the documents on which it is getting trained. Somewhere down the line, this is how we are loading. Right, first we are saving this part we have seen, then we are loading the embeddings, and over here it is utilizing the similarity search, right? Even over here it is utilizing the similarity search. So why is it not getting loaded? All right, guys, it might take some time. So let's do one thing. I do have this application created. So I'll just copy paste and show you. All right, let's new file. I'll call this PDF chart 2.py. All right, majority of the functionality is same as you can see. And if required, I can use this OpenAI API. That was a different API. Now it is the same as the one which I've used in the vector store, vector.py. All right. So it's the same API key. This should work. As you can see, it is the same code, right? It is pretty much the same code, except for the fact that over here I've utilized this one in PyPDF code. I've set up the name module part as well. So this is the API key, and where this is the API key. Where else one is the API key over here. So as of now, as you can see, guys, this is how I've set this up, and that's it. So this part of the code refers to that we are utilizing the same module, right? We are utilizing the same module. Let's run this. Over here, I'm stopping this. Debugging might take some bit longer. So over here, I'm utilizing this. Streamlit run by PDF chart 2. Okay, the path is different, right? It is vector underscore store. The path is different. It is vector store. This is what I've set up. Vector store underscore DB files, right? Okay. So guys, as you can see, this is the budget. Fiscal deficit, just read the definition. This is how it is defined, right? And what we are getting, are we getting the same response? Are we getting the same response? Yes. Okay. Now let's increase the complexity. Now the PDF I've chosen is it's not a simple PDF. We do have information present in form of tables as well. All right. We do have information in form of table as well. So let me ask. So what is the total expenditure of Government of India? All right, for 24-25. This is the information, right? This is the number. Okay, as of now, I've not mentioned the year. Is it fetching the relevant information? Expenditure of Government of India is giving some different information, right? 7836184. Is it present somewhere else as well? Is it present somewhere else as well? Effective capital expenditure. I think it must be present somewhere else as well. Must be present somewhere else as well. Okay. Let's try questioning something else. Sources of financial. Okay. Let's do one thing. Let's ask this question. See, what are the sources is it listing? Market borrowings, security against small saving, short-term borrowings, market borrowings, securities against small savings. Are we able to find this information? So just try to understand the LLM along with RAG is capable of drilling down the tabular information from PDF as well. Yes. State Provident Fund, external debt, yes or no? Explain sources of financial deficit and its amount. Okay, so it's not displaying the amount, right? Grand total, okay, let's try to extract grand total of this grand total of sources for 2024, 2025. See, even after that, let's say the state of perfection is not something we should expect. So, okay, grand total, what it is displaying, 1472915, right? 1472915. All right. 147. Okay, see, this is the number it is displaying. 1472915. Are you getting this? Means it is not generating any random number, even though it's not correct. This is what I was expecting. But as of now, what it displays is this number. All right. Okay. Now let's ask a completely irrelevant question. Let's ask. Now, by any chance, do you find this? Question can be answered utilizing this PDF. As you can see, yes, even I've explored the graphs as well. Yes. Okay, let's query the graph. All right, trend in tax receipts. For RE 2324. All right, okay, let's explore these two. All right, let's explore these two. See, whatever I've mentioned for BE, and what is the next one? RE 2324, right? And RE 2324. Okay, so I need to see the percentage, right? Okay, let's, okay, so what is the percentage contribution of direct tax and indirect tax? All right, see, percentage contribution of direct and indirect tax. Okay, 5.1 indirect taxes, percentage contribution of direct taxes 25.8 and indirect taxes 5.5. Okay, it is not giving the exact result, right? Is it possible that we have similar information elsewhere? Expenditure, while for RE 2324, the percentage contribution is 23.3 and indirect taxes 4%. That is not the case, right? That is not the case over here. I'm getting different data. Okay, let's try to explore something else. Explain composition in terms of contribution. Let's see. Okay, see, if this is spelling error, then that's an error on my part. Just have a look. Okay, let's the composition of expenditure can be explained in terms of percentage contribution as follows. Now, 11.1, 3.9, I don't see these numbers over here. Okay, let's explore for BE 2024-25. BE 2024-25. Are we getting the same numbers? No, where is it fetching these numbers from? 11.1 other grants, loans, centrally sponsored scheme. See, at least these names are correct. Just try to understand. To get these names, you have to drill down into the chart, right? These names are correct? Yes or no? Please check. Are we getting the correct names? Yes. Okay. And it's not just that. I can even query in Hindi. It's not, let's say, language. It is completely language independent, right? I can query even in Hindi. Let's see. Okay, now I don't have the Hindi keyboard. Okay, so it is given 20.99 lakh crore. Lakh crore. Um, okay, let's try some mix for RE23. Okay, for 2022-23. See, over here it has fetched this number. For 2022 and 23, it has fetched this number. Okay, let me further augment this. Now, guys, let's have a look. Okay, now I think it is fetching information from a different chart, maybe. Definitely, it is not this chart. Okay, let's ask something contextually from this outside of charts in Hindi, all right? In Hindi. Let's drill down. Composition of transfers to states and union territories. The entire data is in tabular form, right? Do we have some context? And so there can be many charts related to even a single topic. So that might be the case. Okay, let's try to explore something else. Is it not getting popular? Okay. Okay, let me scroll down. Let's explore something else. Okay. Let's explore some other charts in case we will have some. Let's explore the English version of it. Let's summarize this. So guys, as you can see, this is the result that I'm getting. So when we are utilizing RAG, means definitely we have not reached perfection. There are, let's say, we are still getting errors, but definitely it's an head forward towards the optimization. All right. Are you getting this? Guys, is this clear to everyone? Please respond. Guys, is this clear to everyone? Please respond. All right. Now, because we are short of time, so I'll show you, let's say, how to implement this. The SQL part of the chatbot. I'll show you, just give me a minute. So this was just one application. This is PDF chat. I'll be sharing the files. Don't leave the session yet. And then over here, I'm creating another file in the same folder. Right, and this is going to be, let's say, SQL chat dot py. All right, guys, I'm utilizing an API key. Just observe the code and just try to follow along. We have already set up MySQL. Over here, I'm utilizing, let's say, LangChain provides SQL database and SQL database chain. Over here, the code is quite crisp and not much detail. Over here, I'm setting the OpenAI API key. This is the Chat AI, Chat OpenAI key. And this is my SQL URL. I'm utilizing a particular database, right? It's a very small database. Let's say over here we have very elementary tables like students, sports related stuffs. And then this is my connection string, right? So this is my connection string. The root is the username. This is my password. This is the host. This is the port number. Just try to understand. This is username, password, then host, then port number, and then the database. All right. This is the connection string. So from LangChain utilities, I'm connecting to this, let's say, URI. All right. This is the connection string. So this is how I'm connecting it to the database. And then in the DB chain over here, I'm utilizing LLM, which is Chat OpenAI. And over here, let's say by default, it's going to be GPT 3.5 Turbo. I'm passing DB and verbose is set to true. First of all, over here, I've used a function called LangChain chains create SQL query chain, right? So there are two things essentially. First, I need to convert, suppose I wish to query my database. So first of all, I need to convert the text to SQL query, and then I need to execute the SQL query, right? So both of the things I'll be implementing over here. Let me stop the server. All right, what I'm going to do over here, just have a look. In LLM chatbot, this generates SQL query. What it is going to do, it is going to create SQL query chain, then chain invoke, and then over here I'm replacing it, right? Then as you can see, I'm replacing it. I'm replacing backslash and we may end up encountering backslash. So this is simply going to create SQL query chain is simply going to convert your prompt into the SQL query. And then this retrieve from DB or query means we can fetch from query as well. For that reason, I've imported my SQL connector. But as of now, I'm just utilizing DB chain query. So the query that I'll pass over here will be utilized here. And then I'm passing the context. And then it is going to return the DB context, right? So first of all, over here, just have a look. I'm converting text to SQL and chat with database. So there are two steps. First, I'm converting text to the SQL and then I'll chat with the database. So ask the question about database tables. I'll pass the user question. User will pass the question. Then I can mention the question as the user question. If at all there is a user question, then it will simply generate the SQL query and then we'll generate the output for the SQL query. Utilizing this retrieve DB from DB or query. So let me run this. This is streamlit run SQL chart.py. Now guys, just have a look. Over here, let's say find all students. So there are two steps who belong to Delhi. This is my, let's say, query, right? Just have a look. Is this a SQL statement? Is this a SQL query, yes or no? Means I'm just wrapping it up. So the guys just have a look. Over here, it has generated the SQL query, right? Just have a look. And over here, I'm generating the output. These are the students because I've connected with a database and that is how I'm getting the response. Is it clear to everyone?
Did this masterclass spark your AI curiosity? Don't let the learning stop here. Like this video, subscribe to our channel, and share your thoughts in the comments below.